Hello and welcome to DevFest 2020. I'm Jason Titus, VP of Engineering at Google, joining you from my home in California. Each year, we at Google truly feel the anticipation for DevFest. It's a one-of-a-kind series of developer conferences, and we're glad you can join us and the local developers within your community. Your local DevFest event this weekend is one of hundreds taking place all around the world right at this moment. And what makes DevFest truly unique is that it's run by volunteer community organizers on a mission to help other local developers grow and share a passion for Google technologies. Let me introduce you to my teammate, David, to share with you some great examples. Welcome, David.
Hi, Jason. Thank you. And welcome everybody to this year's DevFest season. I'm David McLaughlin, Director of Developer Ecosystems at Google. So I've been with DevFest since the very first year in 2010, when I was able to join a large percentage of them. Back then, they were a series of targeted events in just a handful of countries. In the years since then, we've had massive growth to countries all over the world. I'm happy to be able to continue this celebration of developers and tech in a new virtual format and bring people together to learn and to share what we're all building. Now let's take a look at a really inspiring story from Uganda. It shows how a community member started learning about machine learning and ended up building a really nifty app using TensorFlow that detects diseases in plants and helps farmers reduce crop devastation. Take a look.
Growing up in the city, I never expected to work in agriculture, but when fall armyworm attacked, it affected us all. Since its arrival in 2016, this crop pest has caused massive devastation. I've met farmers who have lost everything.
Tubadde tukozzaako ddagala okulaba nti akako okulya ki kasooli. Naye akantu ako tekayinza kumalawo obulwadde obwo ssebo.
So I wanted to use my skills as a software developer to help. At a Google Study Jam, we taught ourselves TensorFlow. We started by building an Android app on top of an open source API. The app allows farmers to spot infestations early, far beyond the capability of human eyes, and suggest an effective treatment. When I was younger, I didn't know what I wanted to do, but then I discovered app development, and I was excited to show people something they never thought possible. Machine learning gives us the advantage against fall armyworm, ultimately saving harvests and reducing pesticides.
Kunkyusizaamu kubanga taata oba jjajja teyalina ennyumba y'ebbaati. N'ebbaati nazimba ennyumba yange nga tetoonya. Tulina essuubi ne tufuna embeera ennungi mu kulima.
We are just getting started, and there are so many other sectors like health and education that machine learning could really improve. Farming is a crucial aspect of life in Uganda, and I feel proud I'm part of a team driving to ensure our culture can continue.
Earlier, you saw a beautiful inspirational video about how machine learning and Android were used to create an app to detect crop diseases. So for DevFest, I wanted to get together a few of my friends from Google and beyond to show you how you could get started in building something just like that from scratch in a few minutes. We'll build an Android app and a web app.
I want to create an app that's able to recognize information about plants. It's going to need camera functionality as well as machine learning inference. Let's see what that looks like in code. The app is written in Kotlin and uses Camera X to take the pictures and MLKit for on-device machine learning analysis. The core functionality is in Take Photo, where we take a picture, analyze it, and display the results. First, we call Take Picture on a Camera X image capture object that was created earlier. One of the parameters is a callback object, which has this on-capture success function. We get the received image into the format we need for MLKit. Then we create an image labeler object and process the image. When this succeeds, we receive a collection of image labels, which we turn into text strings and display a toast with the results. Let's see what the demo looks like. So we'll take a picture and it says, I see an insect and a plant. So that was pretty easy, rigging up Camera X and MLKit to detect arbitrary objects in the camera view. But the results were pretty generic because the data set didn't have enough information about our domain. So let's dig a little deeper.
Okay, let's go deeper. Now we need a model for something very specific, detecting diseases in bean plants instead of cassava. Let's explore how to build it. On this guide, we will use some of the great TensorFlow tooling available. Let's start with Colab. You can understand Colab as a cloud-hosted development tool. We will do all our coding on it, and you will not need to install anything on your machine. Let's start with a new notebook. Let's just turn the title to beans. We will need to install some packages that we are going to use later. These packages are not installed on your machine. They are on a cloud machine that was created for your Colab. Nice, it finished installed the packages. Let's download the data and do some visualization to understand how our data is separated. Perfect. We download the data. Let's take a look on some of the images so we can have a better understanding of what we are doing here. Here they are. These are some of the images that will be used for training our model later. Now we have the data. We need to create a model. We are not going to create one from scratch. We are going to use a technique called transfer learning. TensorFlow Hub is a repository for TensorFlow models. You can find all kinds of models here. Let's start with this one. Let's go back to our Colab. Let's define a model handle. Nice. Now we have the data and the base model. How can we do transfer learning? To do that, we are going to use one of the tooling that I mentioned before called Model Maker. Model Maker makes your life way easier when you need to do transfer learning. Let's create the spec for our base model. Let's create our train variables here using the dataset beans that we've just seen. And now we are going to put everything together with Model Maker by defining a model with the training data and the spec that we got from TensorFlow Hub. This will take a couple of minutes. It finished training. And as you can see here, our accuracy is at 87%. Of course, let's evaluate the model with some data I didn't see yet and see how good it is. Nice, 95%.
The TensorFlow Lite model Gus just created contains all the metadata Android Studio needs to recognize it and automatically build classes for it.
To get started, you can update your build.gradle file to include the following TensorFlow Lite dependencies. Then, you'll want to import your generated TF-Lite file into the ML folder of your project. Let's check out the details of our imported model. From here, we can see an example of how to use the model in our app. Let's move over to the main activity class to take advantage of it. Inside of our image capture callback, here on line number 78, we create an instance of our model. Next, we use it to process the captured image here on line number 84. And finally, here on lines 92 through 98, we display the results of consuming the output inside of a toast message. Let's run our app. Now, instead of telling us it's looking at a leaf or a plant, it can actually tell us if it's looking at a bean leaf and give a diagnosis. Sweet.
So this concept works, but it's very much a raw demo. What if we want to make this a more successful app? Well, we'd probably need to add services like authentication so our users can sign in, analytics and A/B testing so we can find out how our users are really interacting with our app, some crash reporting or performance monitoring, and an easy way to save our users' data to the cloud. Luckily, that's where Firebase comes in. Now, the new and improved Firebase plugin in Android Studio makes this simple. I'll start by adding some analytics so I can find out exactly how our users are interacting with our app. And the plugin does most of the work to get the library integrated into my project. Now that I've done that, well, we can get an instance of the library up here, and then we can log what kind of results we're getting from MLKit. And then once we've done that, there's a lot of ways to get at this data. It'll start showing up here in the Firebase dashboard, but I find one really fun way of viewing this data is to use Stream View, which kind of gives you a real tiny sample of what kinds of analytics results we're seeing. Looks like I've already recorded several of these select content events, and I can dig into these event properties and see what kinds of results our users are getting. And I could start using that information to maybe refine my MLKit model or A/B test different alternatives. Firebase helps you build better apps, and analytics is just the tip of the proverbial iceberg. Maybe we could let our users upload their own pictures and store them in the cloud using cloud storage for Firebase. There's so many possibilities.
This is a sample app, but if we were to productize this, it's important to keep in mind how our AI design decisions impact our users. For instance, we need to consider if and/or how it makes sense to display confidence intervals to help your users interpret the ML model output. Or say how you design the onboarding experience sets user expectations for the capabilities and limitations of your ML-based app, which is vital to app adoption and engagement. For more guidance on AI design decisions, check out the People Plus AI Guidebook at pair.withgoogle.com/guidebook.
And don't forget about the web. I've built a PWA that can be installed across all your users' platforms. It combines the web camera with TensorFlow.js, and by integrating machine learning, we can make an amazing experience that runs across all browsers.
This isn't a finished project by any means, just a proof of concept for how a minimum viable product with a roadmap to completion can be put together using Google's developer tools and APIs.
You might also want to open source this project too. We'd love to help you with this, and you can learn more about the process at opensource.guide/startingaproject.
Hi, developers. My name is Annie Jean-Baptiste, and I'm the head of product inclusion at Google. The demo you just saw shows how Google's products can come together to create an amazing app. But what about product inclusion? You may be wondering, well, what is product inclusion and why is it important? At Google, we believe that giving power to new voices is the core of innovation. When we bring an inclusive lens to the product design process, we amplify underrepresented voices and allow all users to feel seen and validated in the moments that matter for them. We look beyond ourselves and seek out diverse voices to shape the products that we build. We also believe that we have a responsibility not to disappoint our users, no matter who they are, what they look like, how much money they make, who they love, how old they are, or anything that makes them them. And so when you're developing your own apps, I challenge you to incorporate the principles of product inclusion into the design process, because we believe that you can do well and do good by being intentional about including underrepresented voices at key points in the product design process. Remember, those closest to the problem are also closest to the solution. You can learn more about product inclusion at Google by visiting accelerate.withgoogle.com.
Hi, everyone. My name is Jen Cole, and I'm the Global Developer Communities Program Manager at Google. Now it's time to meet and hear from your local developers. These sessions will cover a variety of technologies, such as Android, Google Cloud Platform, machine learning with TensorFlow, web, Firebase, Google Assistant, and Flutter. Follow @GDG on Twitter for highlights from DevFest around the world, and try out the DevFest AR filter and avatar. Share what you're learning or your favorite part about the event on social media with #DevFest.
Hello everyone, I'm Louisa from the Google Developers team, and I'd like to welcome you today to the very first UK and Ireland DevFest. We're really sorry we can't be together in person, but I know you're going to have a brilliant time with us today, as it's a rare opportunity to get to hear from and interact with developers from across the UK and Ireland and beyond. I'll hand over to Jen now, one of the main organisers of today, to tell you more about what we've got lined up for you. Enjoy DevFest.
Thank you, Louisa. Hi everyone, I'm Jen Ashley, and I'm one of the many GDG leads who are delivering this event to you today. There are 16 Google developer groups who came together to plan and create a wonderful event for you. We are also joined by 2 developer student clubs who have been very active in spreading the word to the student community in the UK and Ireland. I feel very fortunate and happy to have worked with these 29 other individuals to deliver this to you today. Please meet the team. So thank you to this wonderful team, and to you, our attendees and speakers. Thank you for being here, and enjoy the rest of the conference.
Hello! Finally, the wait is over. So finally, we are here in the GDG UK and Ireland DevFest 2020. Thank you for attending. My name is Ricardo La Rosa. I am a GDG Cloud Dublin organizer, and also I am a software engineer at Workday. I will co-hosting today the hot tech track today. We are going to have 12 speakers, and it's gonna be awesome. So we have multiple topics that will be very interesting, and also a lot of surprises and prizes there. How we are going to organize the tracks? So we are going to have 4 blocks of 3 talks each one, and we are going to have between them a coffee break, and our lunch break is going to be around 1:45 p.m. So I expect you to enjoy this day, and thank you for attending. So right now I'm going to introduce my colleagues, which are part of the GDG UK and Ireland community. So thank you so much. But first, I'm going to give some information that will be useful to you. Go to this website and have some, try to read that we have 6 principles of code of conduct. Also remember to include the hashtag DevFest and the hashtag DevFest UKI in your social media. We are delighted to see your screenshots and see all the media that you are going to share there. So as I mentioned, we are going to have an initial block that will be 3 talks. So our first talk is How Good Are You at UX by Rupert Whitehead. And then second talk is going to be Image Adversaries 101 by Sayak. The third talk is going to be My Journey of Building Robots by Selin, Alara, Ornek. So thank you so much for joining us. And I'm going to introduce you to Kartik. Hi.
Hi. How are you doing, Ricardo?
Emma. Hi.
Hey, Ricardo. Hey, Kartik.
Hey.
Excited about the talks?
David. Hi.
Yeah, can't wait.
Hey, guys.
So I'm going to leave you there, and thank you.
Okay, thanks, Ricardo. So as mentioned, I'm Hemel from GDG Edinburgh. And as Ricardo just mentioned, we've got a great variety of talks lined up. And to kick off, we've got Rupert Whitehead, who's a strategic partnerships manager at Google. And he's going to be asking, how good are you at UX? So when you're ready, over to you, Rupert.
Hey, Rupert. Great to see you, buddy. Just a quick background. Rupert was my regional lead for a good many years. I don't think the GDG in Ireland and the UK would be in the same place as it is right now without him and his influences. Rupert, how are you today?
Very good, thanks. It's good to see you again, David.
Yeah, you too, Rupert. Listen, we had a little chat beforehand, and I just had a quick question, but I know you're anxious to get into your talk, and everybody is really excited to hear what you have to say. But I know when you moved from our regional lead, you went to become a go-to-market lead for a better web. And what is better web? What is it you're working at?
Well, essentially, there are 3 big components to this concept of better web that we're driving from the go-to-markets team. One of the pieces is UX. A second piece is faster websites, and the third is around developing progressive web apps. And so what we see is that as developers and as people put more time into making sites more usable, more fast, and implementing progressive web apps and the great functionality that comes from that, we see those sites converting better and being much more effective for users. And so that's something we really want to advocate. We want to advocate to our partners, we want to advocate those to agencies, and we want to really try and move the ecosystem. So this is figuring out how we can work together from our sales team and from within our sales engagements to try and make this movement.
Of course, and the better web and Google being not an evil company means that it's not just a better web for able-bodied people, it's a better web for those who have difficulties in different areas as well. Would you like to expand on that a small bit?
Well, absolutely. I mean, I think, when you're looking at usability in particular and UX in particular, you need to design for everyone, and understanding what those personas are, where their journeys are, means that you can create more inclusive products, more inclusive experiences, and ultimately that delivers a lot more value to you and to your customers. So to me, I think it's a fairly obvious that you need to do this, but it takes time and it takes focus to be disciplined about how you go about designing for inclusivity.
That's a very noble goals, Rupert. Listen, I know we've taken up enough of your time, and you'll be tight anyway because you have a lot to tell us. We'll hang around in the stream, and if you'd like to start your presentation, we're delighted to hear what you have to say.
Sure. Let's see. Just going to share my screen now. Great. Are you? Hopefully, you should be seeing how good are you at UX on the screen now. Essentially, what we're trying to do here is I'm going to give you a quick summary of the approach that I'm going to have throughout this presentation. First of all, I'm going to explain a little bit about why UX is important, and then go into a little bit about how we've actually tried to answer this problem, how good are you at UX, to create a model that people can use to analyze where they are in terms of their usability journey and their UX journey. And then look at how you can put that into practice as well. So there's quite a few different pieces going on there. First of all, understanding why UX is important and what's led us to this position to create this kind of model, and also how you can use it. So with that, let's have a look at why UX is important. And I'm going to start off with this slide and this concept from McKinsey. So McKinsey have seen that design-focused companies show 32% higher revenue growth and 56% higher total returns to shareholders. And that's way, way faster than their industry counterparts did over a 5-year period. So if you're looking at this from a board level position, so, as looking at shareholder value, it's really, really significant that you invest in design and good UX, and that becomes really core as a proposition. So I guess as a starting point, I just wanted to position this as something that really needs to be elevated as a concept, and it really reaches the most top levels of an organization. In terms of why UX matters, it actually matters to pretty much everybody. I'd like to explain a little bit about why it matters to each of these different groups. For websites owners, if you think about the conversion funnel, if you think about user acquisition, if you think about retention, if you think about engagement, and if you think about return on ad spend, all of those things are massively impacted by the user experience of your site. So if your site is not really designed to be effective, as effective as it could be on all of those pieces, you're going to be losing quite significant money at that time. And you're not necessarily going to be as competitive as you could be compared to your to other people in your field. Ideally, I want people not necessarily to compare themselves to others in their field. I want them to compare themselves to being the best that they can be. And in fact, that whole concept of better web is about improving people to challenge themselves against where they are. So that's website owners. For agencies, think about consultancies, think about systems integrators, think about companies like Merkle or large companies providing professional services. UX matters to them because they can be providing the services that help companies get better. So if you're helping a company get better, you can monetize that. So that's really important to them. And they often feel that they are advocates for the users and advocates for the website owners. So it's quite important for their business models to be able to deliver this kind of thing effectively and help the website owners on their transformation journey so that they're beginning to be better and constantly improving on that acquisition, retention, and engagement type of piece of the funnel. For Google, it's really important for us. It's important for us for two reasons. I mean, the first is the health of the web is really critical to us, and we really want to put users first. And this is essentially what user experience is all about. The second piece of it is really very fundamental to our business model as well. So if you think about good user experience, that drives faster and better converting sites. And those converting sites mean that people will get a better return on ad spend, and that's going to help us as a company. Then for developers, I think we often overlook this, actually, why UX is really critical for developers. But if you're there as a developer and you're building the wrong thing, that's a phenomenal waste of resources and time and effort. So if you have a really decent UX community around you and a decent culture of user experience that's embedded in your organization, it means you're building the right thing. And that's the right thing that's going to be delivering to your business goals. And I've left the users till last. And of course, in a sense, they're very much the first and the obvious piece of all of this. But all of this is grounded in the users. So we want users to have the best experience possible. So it's just seamless and easy for them to get to the information they want, activate the service they're looking at, and be effective in the journey that they're taking. So hopefully you see why UX is really critical for Google and all these other stakeholders. What's quite nice about this is that it feels like everybody wins. This is a world where, you know, there are benefits for everybody. So, you know, that sounds great, but I see still a really big gap. We know at the top level this is really important to stakeholders. We know it's important to all of those different groups that we talked about, and particularly shareholders as well. Yet we're not seeing companies invest in this area as much as we'd like. And that's problematic. It's problematic because it means we're not getting the experience to the users that we want, and everyone's losing out. So how do we solve for this? And essentially what we've done when we've looked at this is tried to break the puzzle down into different pieces of the problem. So first of all, we thought, hey, if we had a model that showed what good UX looks like, that would be a really good starting point. Because what we often see when companies are looking at UX is that they take it in kind of an episodic sort of approach. There's not necessarily a full culture of UX that's there. Instead, what you have is an approach where you're looking at different pieces of the puzzle, and you're not necessarily looking at a holistic level. So being able to take a step back and going, what could this look like, is a really good start. And also understanding what the resources available are out there that can get you started on that journey. So first of all, we thought, great, let's put something together that helps map some of those resources and helps identify what good looks like. So people can begin to say, am I entry? Am I intermediate? Am I advanced? Where do I sit with all of this? And where can I go to find more about that? So a lot of that's kind of a learning exercise. Then we thought, well, actually identifying just what good, intermediate, advanced is one thing. So you might know what good UX is. Effectively, what we really want people to do is figure out where the gaps are and self-assess themselves. So in other words, think, okay, I'm going to complete a UX maturity model or something like that that explains where I am I good, am I intermediate and advanced, maybe have a tool, a spreadsheet or something that allows them to self-assess them. That's great. You know, maybe you could see the gaps there, job done, but it's not quite that simple either. The third piece is really, really critical, because when you have these kind of UX maturity models or maturity models that allow you to evaluate how good you are at UX, they're only as good as the actions that are enabled out of that. And so what we want people to do is, once they've actually self-assessed their ability against all of these different UX criteria, we want them to actually create a strategy that they can present to their C-level stakeholders. So in other words, you find a C-level sponsor who can actually review that strategy and say, that's good. I think we should invest more. Here's more money to be able to do it because I see the business value in that. And I see very concrete, clear asks. So instead of small UX requirements coming out from various different teams at different times, as often happens, this allows you to take a more consolidated strategic look at that problem and then really look at the investment landscape that could go behind it. So that's really the approach we're trying to pioneer here. And we're very early in this as well. So expect changes as we go through this approach. But out of that, what we want to see is that company investing more and driving that change so that we actually close that gap. So how do you go about building a UX maturity model? Actually, UX turns out to be a huge field. So what we wanted to do was try and find ways of simplifying it down into different chunks of pieces that seem to sit across most of UX as a field. And it is a broad field, and it's difficult to find a very consistent way that talks about every piece of that. So what we've tried to do is find some chunks of things that we see as common across UX that are things that we could do a lot more of. So the first piece of that is about discovering and diagnosing. This seems to be common to UX across the board. You need to understand where the problem is and what the problem is. That's really fundamental. So lots of techniques and approaches that you can use, and we can cover a few of them in a moment. I'm not going to be going through the entire maturity model in detail here, but I want to give you a sense of how we're approaching this. But that was really the starting point. Then once you've discovered what the problem is and understood where that maybe fits in with your business goals, you're then going to come up with some ideas of how you solve for this. So thinking about the ideation side, brainstorming what the different types of solutions are, looking at design sprints, figuring out what are the right ways of solving the problem. Really important there, again, back to where the value as a developer. If you're building on the wrong idea, that could be wasted investment. So understanding and going through kind of a divergent process to look at lots of different ideas is really important in this phase as well, so that when you actually come to the right solution, you're coming to a solution that's going to work well. Then the final kind of piece of this at the high level is around proving the concept. So these you can think of as pretty sequential. You start off with discovering and diagnosing a problem and that might be surfaced from your analytics or from interviews. You come up with solutions from that. And you might be doing that through design sprints, for example, and then you go on to proving the concept. And that's really how you test and prove that solution and demonstrate that it actually works. So, in the solution ideation phase, you might be looking at prototyping, you'll be thinking about hypotheses to test, remote user testing labs, all of these kind of things. And then proving the concept, you'll probably be rolling out A/B tests and looking at how you can check that your hypothesis that you had that came out of the discover and diagnose in the solution ideation phase, how that can actually be tested in practice. And so you might send half of your users to one implementation, another half to the other, and see what the impact is in terms of the metrics that matter to you. So what you see there is a kind of a nice flow between discover and diagnose, ideating around the solution, and then proving the concept afterwards, which is I think consistent for most companies, that they have a look at these things in these terms. But underneath all of that, there are a lot of other capabilities that don't necessarily sit in just one piece of this. In other words, the discover and diagnose phase, or the solution ideation phase, or the proving the concept phase, but they actually apply right across all of them. So selling UX is really important. Well, clearly for an agency and a third party, they've got one notion of selling UX, and they've got to think about their capabilities there, about how they tell their story, how they bring that proposition to the customer. But actually, selling this internally within your company is a critical capability as well. If you're not very good at telling the value of UX to your company, you're not going to get the resources and the investment in to be able to allow you to do all of those important things in the discover diagnose, solution ideation, and proving the concept phase. So really important you get selling UX right. And there are capabilities around that. We see some companies being quite basic at that and some being a lot more advanced. Then you have content UX and information architecture. So think about the UX of the content you're actually writing on your site. That's often overlooked and it's sort of handed to people, but thinking about what the voice of your site should be. What are the best practices around that? Who are you designing for? Really understanding that well and being rigorous and thinking about it carefully and structured about that can make an enormous difference, as can having the right information architecture. So your site becomes a lot more navigable. As with many of these things, you'll find elements of content UX and information architecture will be surfaced through the discover and diagnose phase, solution ideation, improving the concept. But there are definitely some tips and tricks and resources that can really help by having that specific lens. We talked about accessibility, well, so inclusivity at the beginning of this talk, as David was stressing the importance of that. And actually, I think inclusivity in design is really important. And accessibility is a strong pillar that goes across these pieces. It's thinking about who your audience is and making sure you meet their needs in the design that you're actually producing. So there's lots of best practice around that. Again, making sure that people can think about what really good looks like and aspire to that. And then application of modern web technologies is critical across the board. But if you're a designer and you're not aware of all of the superpowers that the web now has, then you're not necessarily going to be able to activate all of those good things and surface them to your users. So understanding what progressive web apps can do, understanding how form pre-filling can make a much smoother experience, understanding things like how sign-on, very simple sign-on can work and create a simpler and easier experience for your customer, or how to make a much more accelerated checkout or payment flow. Understanding those capabilities is really critical, but it needs to be fed back into the design and implementation process as well. And then there are other tips to drive UX change. We'll touch on that at the end. It's less of a critical one in some senses, but it's more of a kind of a grouping of patterns that we see as very immature companies start off in terms of their UX journey and where they go next. So that gives you a kind of flavor of an overview of the model. In terms of the discover and diagnose phase, I mean, I'm not going to go through examples of every one of these, but imagine that there were similar types of slides that I'm about to show that represented or were an analog or a connection to each of the kind of boxes that we've got. So what you see in the model for the discover and diagnose phase in the slide set that I'll share afterwards actually, is first of all, we explain why it matters. And so you get a kind of a brief summary of why this is something you should probably look at. And so unsurprisingly, a measurement strategy allows you to really be data-driven in your decision-making, so that you can tie things back to the business investments that are important to you and really make informed decisions. So critical on that side. And then, and I know this goes into very small font here, for each of those things, what we want to do is give you a sense of what entry, intermediate, and advanced is. So for discovery and diagnose, you'll see that actually understanding what your business strategy is really fundamental. So you've got to understand the engines of growth for you, what you're trying to do with your website, what success looks like. Is that about conversion? Is that about people going through a funnel quickly? What are the things you really need to measure for? That's kind of the root basic sort of foundation that a lot of this is based on, understanding the analytics of all of that. And so as you look at that, Google Analytics is going to be important as a tool, but also understanding generally qualitative research methods, things like the double eight model, the double eight model as you sort of go through. And essentially what you're trying to do is get people to understand and have really informed decisions about what they're looking to solve for. And analytics is the foundation for all of that. The other thing that kind of comes across in the discovery and diagnose phase is the importance of being able to visualize data and share that with your stakeholders to drive action. And so the dashboarding around some of these UX pieces, the way you take data and information and put it into context so that people can make informed decisions is really important as well in this phase. So loads of great resources on the right that are links for people to explore afterwards. But the idea is that you get this notion of different levels that you can look at and different levels of what good could look like. There are a number of omissions in this, so it's not meant to be an entirely complete UX, sort of everything in UX. There are areas I'd like to have covered, but it's been a bit difficult to. So localization and internationalization, I think that's something we'd like to add in the future. Fonts and typography, you know, they can be important from a UX perspective. Service design is a wider concept that UX is a part of. We focused really on web and also app in this model. So you'll see some app heuristics and things associated with this as well as the web ones. We haven't covered every web capability out there. So things like, I don't know, WebXR may not be covered and so on. And then, you know, I think we'll be adding a few more bits of guidance in the future on app heuristics, but there's some basic ones at the moment, but that's what's coming. In terms of the approach, originally we thought, great, you know, just say where you are. Are you entry, intermediate, advanced in each of those categories? And actually that didn't really work for the objective we were going for. Then we thought, well, maybe this will be useful benchmarking, you know, so are you going to be in a situation where you just say this is good? But again, not really our objective here, because unless you have the same person running all of these tests, and we're not planning to do that ourselves centrally, we're asking people to do it themselves on their own sites, benchmarking is not going to get work because everyone's got a slightly different way of interpreting the results. It's instead, what we've asked people to do is complete a self-assessment that looks a little bit different. It doesn't look at like the standard model we touched on earlier. Essentially, what it's trying to do is take this down to about 100 different yes-no questions, and then you really challenge yourself and think, could I apply this capability, this thing that I may or may not do already, could I do more on that? And if I could, what are my next steps to invest in that? So essentially what we're using for this here is really to help somebody who's building a strategy look at the gaps and figure out what they could do and then figure out what the priority is. The other thing to mention here is it's about solving the right problems in the right order. So if you start off, you should be focusing on the entry level things before you tackle the intermediate ones and before you tackle the advanced. So the objective is not always race to advanced, it's make sure you cover the basics first and do those well. So kind of think of this as a pyramid. Don't tackle the things higher in the pyramid before you've actually focused on the basics. So that's what we want to come out of the self-assessment. And then once they've completed the self-assessment, essentially, this is where we want it to go. We've shown them what good looks like, so they've got an idea of some great resources to look at. It's not too heavyweight. We've tried to keep it quite simple, but there's lots to actually look at there. The companies assess themselves. They've used the spreadsheet to do that. And out of that, we want them to create a UX strategy for a C-level review. In other words, they take all of those different observations they find in the gap analysis and they put it into their own business context. And they figure out what the ask is at a C-level to be able to say, this is what we need to do to investigate UX looking better. And it is better UX. It's not perfect UX. UX is a constant journey. But out of that, what we want them to do is be able to go, great, we have a clear story, we know where we're going, and we've got a really thought about strategy. So the objective of all of that is to trigger that endpoint. And out of that, what we want to see is greater investment and focus on UX, and then an ongoing review of those materials in the future. So it's not just a kind of a one-off, but they do another review in maybe another 6 months' time or a year's time. They have milestone progress, and there's really good heartbeat of moving things forward. In terms of if you're interested in this model and you want to explore it further, do check out the slides on, well, follow the link here. So the bit.ly link is better_web_UX_maturity_model, or better web UX maturity model, as you can see there. Have a look at that and see what you think. I think we've run out of time for me to cover some of the specifics here on Amy's model about looking at UX maturity, but that's something you'll find in those slides that gives you a concept of where you could be. So what we see is very entry-level companies tend to be have just maybe a single UXer on the ground. Medium ones tend to have more people on the ground, and high, more sophisticated companies tend to have much more established ways of working, much more ingrained within an agile way of working, and much more of a kind of a full acceptance of that.
That's fantastic, Rupert. Thank you very much. As you've mentioned, we are running out of time. We do appreciate it, and we appreciate the bit.ly link you had up on screen there for anybody that wants to follow up. Rupert, are you happy to be contacted across on Twitter, social media?
Yeah, sure. It's Rupert Whitehead on Twitter. So if anybody's got any questions, let me know.
Thank you very much, sir. Karthik, I think, is going to introduce our next speaker. I will gracefully exit stage left. Thank you again, Rupert.
Bye.
Thank you, Rupert. Awesome. Hi, Sayak.
Hey, hi, Karthik. How are you?
How are you doing?
Sorry?
How are you doing? Are you good?
Yeah, I'm doing good.
Yeah, awesome. So Sayak is going to be talking about image adversaries and he currently works at Pi Image Search. Do you want to just give yourself a quick introduction?
Yeah, sure. So I'm a deep learning associate at Pi Image Search. I work at the intersection of computer vision and deep learning, and recreationally, I contribute to TensorFlow Hub. And when I'm not working, I'm mostly coding or writing up technical articles and speaking up at conferences and stuff like that. So yeah, that's about me.
That's awesome. Aren't you also a GDE in TensorFlow?
Yeah, so there's not a category called TensorFlow. There's actually a category in machine learning. So yeah, I'm one of the Google developers expert in machine learning. Yeah.
That's awesome. How long ago did you get the GDE certification?
Yeah, so I was assigned the status of a GDE on 21st May 2019. So it's been more than 1.5 years.
That's awesome. Awesome. So I know that you've got a lot to talk to us about today. So I'll let you carry on with your slides in the session. Thank you.
Yeah, sure. Yeah, cool. Thanks for the introduction. Okay, folks, I'll share my screen and get started. If someone could confirm if my screen is visible, that would be awesome.
Yeah, your screen is visible.
Okay, cool. Thanks. Okay. All right, folks. Thanks for joining this session. Karthik has already introduced me, so I'm not going to reintroduce myself. Today, I'd like to talk to you about adversarial examples in deep learning, specifically in the context of computer vision. And the part that I missed out on was I like to binge watch stuff on Netflix. So that's why I like to call myself a Netflix nerd. So yeah. And here's going to be the brief agenda of the session. So I'm going to be introducing what adversarial examples are, their types, like natural and synthetic adversarial examples. So some of the open questions that you may have after we are done with the types of the adversarial examples. And then I'll be providing you with some final thoughts, and I'll be concluding with some positive direction as to for tackling adversarial examples in a better way. So however, I do assume you are already familiar with the fundamentals of deep learning, and that you know at least one of the major deep learning frameworks like PyTorch or TensorFlow. And even though all of the stuff that we'll be discussing today will be mostly based around computer vision, but all of these concepts will equally be applicable to other domains as well. For example, natural language processing, audio, and so on. And the concepts are entirely framework agnostic. So feel free to try them out on PyTorch, because I'm going to be showing the concepts and I'll be implementing them in TensorFlow and Keras. So yeah. Okay, so let's start with what are adversarial examples. So to be able to understand what adversarial examples are, we need to go back and take a look at the broad steps that are needed in order to train a very simple neural network. Generally, we start by feeding our network some input data. We generally standardize the input data to some fixed range. We then pass it through the layers of a neural network, and then the neural network gives us some prediction. Then we calculate some loss, and then we take the gradient of that loss function with respect to the learnable parameters of our neural network, and then we propagate those gradients back in order to update the learnable parameters of our neural network. And in the diagram that we are currently seeing here, the parameters are typically referred to as weights, but when I mention learnable parameters, there can be weights, there can be biases and stuff like that. Basically everything that can get updated during the backpropagation process. So that's like the super blazing fast intro to the way of how a neural network might work. I know that this is probably not the most comprehensive introduction of how a neural network might work, but in the interest of time, I hope you will get the idea. So two things to note from the fundamental building block of a neural network working is we do not calculate the gradients with respect to the input data. So if we go back to this diagram again, we take the gradients of the loss function with respect to the learnable parameters of the network, not with respect to the input, right? And also we perform parameter updates such that the loss or the training objective is minimized, right? We would want to minimize our loss or training objective. We wouldn't want to maximize the loss, and we generally calculate the gradient for the loss function with respect to the parameters of the neural network, but not with respect to the input data. So these are two of the primary things that I would like you folks to keep in mind for now, because we are gonna get to this. So what if we calculated the gradients with respect to the input data? And what if the input data were themselves updated with the gradient to maximize the loss instead of minimizing the loss, right? So the previous 2 points might immediately lead you to this consequent points as to what if we could have calculated the gradients with respect to the input data, and what if the input data were updated in order to maximize the loss instead of minimizing the loss. So let's see. So some immediate constraints here, because if we were to operate on the input data space, the input should be updated in a way such that the semantic characteristics do not get changed, right? If we were to manipulate the image of a dog that we'll be providing to our network, the dog should still, the dog should still be visually dog to the human eyes. That visual semantics should not change. So these are some immediate constants that may come to your mind, and we still should be able to update the input data such that we are able to maximize the loss. So these are some immediate constants with which we can formulate further. And you might ask, why gradients only? I mean, why are we calculating the gradient of the loss function with respect to the input? Why do we care about the gradient so much? That is because this quantity will inform us how to nudge the input data or how to change the input data to affect the loss function in a particular direction, right? Because there's no other way to know about how much to change in a particular data space such that our loss function gets affected in a particular direction. And here's the kind of overview of what's coming. So on the left, we see that when this particular image of a panda is fed to a neural network, the neural network is able to predict that the provided image is a panda with certain confidence interval, with certain confidence. And then when we add this kind of weird stuff to this same image, then the predictions of that same neural network get drastically changed, right? And it gets changed to given. Right? It doesn't make sense. It doesn't make sense at all, right? So this is sort of an overview of what's coming. So stay tuned. And if at this point in time, if you have any questions, probably in the interest of time, we'll have to skip them. But yeah, feel free. I'll leave you with my coordinates, so feel free to reach out to me at any point in time. So types of adversarial examples here, because in the beginning of my talk, I mentioned that we will be discussing about mainly two types of adversarial examples in deep learning. One is natural adversarial examples. Another one is synthetic adversarial examples, which we ourselves can engineer. So yeah, let's see. So you can immediately see that I have appended an exclamation mark just after natural examples, because if the examples are naturally adversarial, what the hell can we do in order to tackle that, right? And to further motivate as to why adversarial examples might be implicating some grave concerns, think of a neural network that's deployed in a self-driving car, and it's getting continuously adversarial, it's getting adversaries on a continuous manner from the input data it's receiving. So instead of predicting a pedestrian as a pedestrian, what if the neural network would avoid it as a car, probably, or as a signing board or something like that? The implications would be immediately very grieving. So that's probably why we should care about adversarial examples when deploying our deep learning models in production. So I hope it was sufficient enough to sort of motivate as to why the need to tackle adversarial examples out there in the real world. So coming back to the natural adversarial examples, so here we can see some examples that the authors of this paper called Natural Adversarial Examples have presented to us. So we see the image of a candle is being predicted as a jack-o'-lantern. The image of a dragonfly is being predicted as a sea lion and stuff like that. And these are all, natural, like these are all the original images. These images were not perturbed using the scheme that we just mentioned. What if we were to, change the input data so as to maximize the loss? They were not perturbed in that way. So let's see why our networks might be getting this wrong. And just to motivate this a bit further, so back then when this paper came out in 2019, probably, DenseNet 121, it's a specific type of convolutional neural network. Back then it used to be considered as a state-of-the-art computer vision model. So I'm directly quoting this from the paper. It says DenseNet 121 obtains around 2% accuracy, an accuracy drop of approximately 90%. So the authors actually constructed an entire data set of natural adversarial examples, and DenseNet 121 was only 2% accurate on that data set. So I hope it further motivated you regarding the concerns of natural adversarial examples to be very specific. So let's see what the hell is going on here. So in a typical image classification problem, we tend to associate an entire image to only a single class. For example, in the image that we are currently seeing, of course, it's an image of a dragonfly, but there are other objects too that are getting associated to that particular label, that is of a dragonfly, which is exactly why a dragonfly is probably getting predicted as a manhole cover or something like that, right? Because there are other objects in the image, and when you tend to associate an image consisting of all these different objects to a particular single class level, such as dragonfly, things are bound to get out of your hand like this one, right? And the second observation is color and texture as opposed to shape as the primary descriptor. So there are certain number of descriptors that help us to describe a particular image, and we as humans, we are more prone towards shape as a descriptor in order to understand what a particular image might look like, because a dog has got a particular shape, a monkey has got a particular shape, a car has got a particular shape. So we have this shape based perceptions in our heads that help us to classify a particular image. But in this particular example, we see that's not the case, because we can clearly see that if there's majority of yellow color in a particular image, the image will probably get predicted as a banana, as we can see in the second example here, whereas dragonfly is clearly sitting there. So instead of predicting that image as a dragonfly, the network is predicting it as a banana. So this kind of signals us, probably instead of shapes, the network is picking up on signals and colors and textures and so on in order to develop that perceptual understanding of that particular image, which is pretty disastrous, as we can see. So in case you were wondering, because many of you are probably familiar with adversarial training methods and so on, and as the authors also denote in that paper, robust training methods hardly help, and they also mention about adversarial training, right? So recipes that really show promise, and I'm taking all of these recipes directly from the paper. One is self-attention, amazingly popular concept in deep learning in general, and network capacity. So in order to be able to deal with natural adversarial examples, these two recipes are a must, must to include in your neural network architectures. One is self-attention so as to more explicitly instruct the network that, hey, this is where you should particularly shift your attention to in order to associate a particular image to a particular class level. And you need to also scale up your network capacity in order to be able to model those relationships minutely. So now that we have kind of briefly discussed about natural adversarial examples, let's see how does synthetic example look. So we'll be starting off with this poor hog, because this is the image that will be perturbing in the consequent slides. So let's see. So if you were to run a pre-trained ResNet 50 model on our poor hog, like if you wanted to do off-the-shelf classification with a pre-trained ResNet 50 model, here's how you will probably do it. Again, this is all TensorFlow and Keras code. You will first load up the weights of the pre-trained ResNet 50, and then you will straight run inference after pre-processing your input image, and then you will process the predictions. Now, after we are done post-processing the predictions, probably the predictions would look something like this. Like the first prediction would be hog. If we took top 3 predictions, hog would definitely be topping those top 3 predictions, right? And as expected, the loss, if we calculated the loss with respect to our predicted label, it has to be very low, as we can see, right? The loss is very negligible, in fact. So this is the quantity that we are interested in maximizing by perturbing that image of our poor hog, right? So let's see how we can do that. Now the fun part. So I like to call this as like taming the input data points as attacks. So as we can see, so if we execute a certain number of steps inside a gradient tape context, TensorFlow's automatic differentiation engine keeps on tracking all the gradients that can be calculated out of those computational steps. So let's see this one by one. So now we are interested in calculating the gradient for the delta vector, which is a vector that we would add to our input image, that is the image of our poor hog, and then we will add that delta vector to our image, which is kind of pre-processed as a tensor. Then we will pre-process typical deep learning steps and stuff, machine learning steps and so on. And then we will run the predictions through a pre-trained ResNet 50, and then we will calculate the sparse categorical cross entropy loss with respect to the predictions and the original image, right? And now we will calculate the gradients of the loss function, that is the sparse categorical entropy loss, with respect to the delta, the particular vector quantity that we would ultimately add to the original input image, right? And then we will, apply all the calculated gradients to our delta vector, and then we will clip the delta in such a way the pixel range is still within 0 and 1 after the standardization process. And when you sort of repeat this process, you get a typical loss landscape like this if you are using Adam as your optimizer. And our poor hog remains visually the same, but the network's prediction gets changed to wombat, which is nowhere close to a hog, if I'm not wrong. So the top 3 predictions have got completely devastated, to say the least, and the network is now predicting our poor hog as a wombat. So it's also possible to make our hog a dog, which is typically known as a targeted attack. So let's see that how. So now we are interested, to maximize the probability of the true class, which is hog, and then we are at the same time we are also interested in minimizing the loss for the target class, which in this case is dog. So let's see how can we translate this all into Python code. So it's very simple actually. So we are interested in maximizing the loss for the target class, and then we are interested in minimizing the loss for the target class. So if I repeated target class, I'm really sorry. We are basically interested in minimizing the loss for the target class and maximizing the loss for the true class. So that is exactly what this lines of code will be doing for us. And if we continue the same optimization process, then the network prediction gets changed to Lakeland Terrier, again, which is nowhere close to a hog, I think. So this is probably very funny to me, because the network doesn't have any clue as to what's there in the image just because it's perturbed, right? It seems like a very easy deal, having very grieving concerns. So a little lingo here. So this form of gradient descent based optimization is also referred to as projected gradient descent. And about the delta, the vector quantity that we added to our original input, it's actually completely random, right? And you might be thinking, we use Adam as our main optimizer. So what about the other optimizers? So let's see. So this is sort of the brief loss landscape of all the different optimizers that I personally tried. And this includes Follow, the regularized leader, and highly appreciated optimizer amongst the Kaglers. Then there's Adagrad, then there's RMS prop, then there's SGD, and then there's Adam. So in my experience, I found Adam and RMS prop that these are the optimizers that may fall prey to the attacks. And on the other hand, stochastic gradient descent, the vanilla stochastic gradient descent, Adagrad, and FTRL may not fall prey to the attacks, as we can see. So if we see the loss landscape of all these different optimizers, the loss remains kind of constant, this straight line for optimizers like Adagrad, SGD, and FTRL. So I think that's a good sign. But all of these configurations were kept at same. So in order to make a fair comparison, so I probably used a learning rate of 3e-4, and this learning rate was kept constant for all the other optimizers, including the other hyperparameters as well, such as momentum and so on. Okay, so about the different delta. So just to reiterate, delta is the vector quantity that we added in order to perturb our input space, but our input image looks exactly the same, right? We are not able to, distinguish in this image or the first image that I had introduced. Right? There's no difference. Right? So that's the fun part. And about the different delta. So delta is a vector quantity that we ended up adding to our poor hog. So for FTRL, there's absolutely nothing. But for other optimizers, we kind of have developed some perturbation vector. But for HGD and AdaGrad, this perturbation vectors, did not make any sense in a sense that they weren't able to fool our pre-trained ResNet 50 image classifier. So if you are already familiar with GradCam, which is to say grad class activation map, so it's a interpretability tool that helps us visualize where our network is particularly focusing in order to infer on a particular image. So as we can see for the original hog image, the network is indeed picking up on the right signal, but for our simple synthetic attack and for our targeted synthetic attack, it's still picking up on the right signal. But again, regarding the predictions, we absolutely do not have any clue as to where it's going wrong, right? So this kind of emphasizes on the difficulty to interpret the results when it comes to inferring on the perturbed images like the ones that we just saw. So yeah, just keep this in mind that interpretability aspects of adversarial examples are very difficult, in fact. So how do we defend against this stuff? Because you probably have deployed a ResNet 50 in your production. Probably someone has picked up on the wrong signals and someone is probably launching adversarial attacks against your already deployed ResNet 50. Think of the grave implications that you might have. Think of domains like healthcare and so on, where the implications can get really grave. So here are some pointers regarding that. Well, first of all, it's still active. It's still being actively researched, and a good first step toward defending adversarial example is by training neural networks using something called as adversarial regularization loss. And I have also provided a link that shows how to include the adversarial regularization loss in your normal training loop. So I'll be sharing this deck with you all so that you can refer to it if it's needed. But that may not be sufficiently enough, as we saw in case for the natural adversarial example. And there's this recent trend of noisy student training that shows immense promise. Again, it's a paper from 2019. That's why I mentioned it's still being actively researched. And there's also something known as smooth adversarial training, which contributes to the adversarial robustness of different deep learning models. But on the brighter side, there's this paper directly claiming that adversarial examples improve image recognition. So I think we are indeed toward a positive direction as to, for defending against adversarial examples. And these are some references that I used in order to put together this deck. And my deck is available here. I'm going to be tweeting out the link to this deck. So of course, you feel free to check out my Twitter profile and get the link from it. But I'm going to spell it out for you. bit.ly/IA-101. And I have got an entire blog post around the stuff that I just discussed today. So it's way more comprehensive. So feel free to refer to it and let me know your feedback. And thank you for listening to this talk. And Rising Sayak is my Twitter ID. I'd love to get connected with you all. And thank you.
Awesome talk, Sayak. Thank you so much for coming on the talk. I hope everyone enjoyed that. Next up, I'm going to hand it over to David to introduce the next speaker. Thank you again, Sayak.
Yeah.
Hi, guys. Great to be with you again. Our next guest is Selin, Alara, Ornek. Here we go. Hi, Selin. How are you?
I'm great. How are you?
It's great to have you with us today. I'm sure your talk is going to be fantastic. When I knew you were going to be coming on board, I remembered your name from a couple of years ago, and I didn't know where I remembered it from until I did a quick Google, and I found that you were on the Irish news here in Ireland a couple of years ago when you made the journey here with one of your projects. It was IC for you. Is that right?
Yes, it is. I came to a Cool's projects in 2018, and I won the hardware category.
Oh, congrats. Well, I already knew that. That was that was no spoiler there for me. But for anybody else watching, Selin has been over here before, and you've got quite a list of accolades to your name for someone so young. Congratulations.
Thank you.
I think you've done more talks than I have. I noticed that you're a member of the New York Academy of Sciences. It must have been an interesting journey.
Yeah, I applied and I got accepted. Now I'm in the program and having fun while doing the tasks and communicating with different mentors or different people, girls from the other countries.
That's amazing. Did you get to meet Neil deGrasse Tyson?
Sorry?
Neil deGrasse Tyson, the astrophysicist. He's in the New York Planetarium Observatory. I thought he might have been a part of that group.
I haven't met him yet.
So you're in Istanbul, and that's in Turkey for anybody that doesn't know, doesn't have the European geography up to date. So what's the weather like over there now? Are you starting to hit winter times?
Actually, it's quite hot today, but I'm going to go out after this, so I hope it's going to be hot.
So just like your talk, huh? So without further ado, are you going to share some slides?
Yes, I am.
Yes, fantastic. I will remove myself and you can continue with your talk. Thank you again for agreeing to be a part of today's DevFest.
Thank you for inviting me. Hello, my name is Ornek, and today I would like to tell you about my journey of building robots. First, I would like to tell you a bit about myself. I'm 14 years old. I live in Istanbul, Turkey. I am in 9th grade at Tırnak High School. I am also a young member of New York Science Academy and a mentee in the 1000 Girls, 1000 Futures program. I love robots and I'm a maker. I love animals, traveling, reading, books, and gaming. I speak English, Turkish, and French, and I am learning Python and C++. In 2018, I won the first place in the hardware category at Cool's Projects International. The same year, I was also a finalist at the European Youth Awards in the Open Innovation category. In 2019, I was chosen the European Digital Girl of the Year at the ADA Awards. In 2019, I was featured as a dev kid in the Google Developers blog. In 2020, I won the Microsoft Women's Leaders in Technology Rising Star Award. And also in 2020, I have been chosen as a Woman of the World Global Young Leader. My biggest dream is to build a humanoid and to create a vehicle that can travel faster than light in space and send one of my humanoids to the black hole for research. A lot of people ask me how I got started. In 2014, I loved to play Minecraft, and I always wondered how it was made. And I started coding with MIT Scratch. In 2015, my dog Corsan died, and I was really sad. I wanted to bring him back to life. We had a math project at school, and I had to speak to an engineer. While I was talking to him, I asked him how to make a robot dog. He told me to learn about mechatronics. In 2016, I started building robots with MBot, which combines Scratch and Arduino. Then I learned that with Arduino, I can make more advanced projects, so I decided to make Takawolf, a smart color for dogs. The best way for me is to learn by doing. So while making TechWolf, I learned Arduino and C++. In 2018, for more advanced projects, I started to use Raspberry Pi and learn Python and build my robots. I love dogs, so my first project was a smart collar for dogs. My dog Bailey spends his day eating, sleeping, or pinching socks. I live him to pieces and I was really afraid of losing him, so I decided to make this collar. With this collar, if my dog or any dog wearing this collar gets lost, it is possible to send a message to the collar which is displayed on the LCD screen. The person who finds the dog is able to scan the QR code and learn detailed information about the dog. When dogs are scared or on their own, they sometimes bark, cry, or make noise. The sound sensor detects the barking or a noise and sends the notification via the application that I made with MIT App Inventor 2. IC4U, the guide dog for blind people. As I mentioned before, I love dogs, and when I was 8 years old, my dog Corsan died, and I was really upset. Then when on holiday with my family, I saw a blind person and their dog. I thought that if I was so sad to lose Corsan, then they would be really upset too, as not only would they lose their best friend, but their eyes again. Before I start building my robots, I decide what features I would like to add. Before building IC4U, I got in touch with the guide dog associations in both of the United Kingdom and United States. I learned how they train, how they behave, and their relationships with the blind person. A guide dog needs to obey the commands of the blind person. The guide dog needs to adjust his speed and move in the right direction. They have a sense of location in locations that they visit frequently, but they don't have it when they go to a new location for the first time. I also learned that guide dogs have a special ability called intelligent disobedience, which means that if they sense a dangerous situation or any obstacles such as steps, a hole, fire, smoke, or something similar, they become disobedient and do not obey the blind person's commands. Instead, they take actions accordingly and autonomously. I heard that sometimes a guide dog will not let the blind person cross the road even though the light is on green, as they feel the vibration on the road and they can hear car noises approaching. I was fascinated to add this feature to my robot, but it was a little too advanced for me, so I decided to add sensors instead. In version 1 of IC4U, IC4U can detect the situations with the help of sensors and warn the blind person. I also learned that blind people can use their mobile phones with voice commands. I also saw this as an opportunity to integrate this by building an application to enable communication between the robot and the blind person. I also added a GPS-GPRS shield so that the blind person and IC4U can be traced by the blind person's loved ones. IC4U and I won the first place in the hardware category at Cool's Projects International 2018. I received my award from the founders of Raspberry Pi, Eben Upton and Pete Lomas. I was really happy and wanted to make a more advanced version, so I started to build IC4U too. If you remember, I spoke about intelligent disobedience and how I didn't have the skills, so I added sensors to the first version. However, I learned that if I moved on to Raspberry Pi and learned to code in Python, I would be able to use artificial intelligence in order to add features that are similar to those intelligent disobedience. In this version, instead of using a mobile application with the help of Google Voice, Hat and Google Assistant API, the blind person can give a command directly to the robot. IC4U2 understands the commands stop, slow down, go forward, go backwards, turn left, and turn right. I have also added sit, stand down commands. I have to admit that building these joints with servos took nearly as much time as it did to build the whole robot. This is the code which allows the blind person to give the voice commands to IC4U2. In this section of the code, Google Assistant is activated and waits for the user to say, OK Google. If the user says, OK Google, and the user command, it runs the void and the code in that void with the following command. As I mentioned before, I had a lot of problems with the servos. After a lot of research, I found out that Raspberry Pi prioritizes the processes, and sometimes the servos can be pushed to the back. So, as a solution, I decided to add an Arduino to the system and connect the servos to the Arduino. I made a serial connection between the Arduino and the Raspberry Pi and connected the servos directly to the Arduino. As you see, this Python code sends a signal to the Arduino. The Arduino runs the code and IC4U2 lays down. I'm not able to demonstrate IC4U2's movements as I don't have enough room, but I'd like to share this video with you. Okay, go. Okay, Google. Down. Okay, Google. Up. Okay, Google. Back. Okay, Google. Sit. I replaced the ultrasonic sensor with a camera. By doing this, I was able to add object recognition abilities to IC4U2, so that IC4U2 can now detect obstacles and dangerous situations. I used TensorFlow and OpenCV library and the MS-COCO dataset for object recognition. In order for IC4U2 not to get confused by all the objects and surroundings, I added this dark blue frame, and IC4U2 detects the objects within the frame. If IC4U2 sees a stop sign, it warns the blind person that it has seen a stop sign and that it has stopped for the safety of the blind person. I have also added a conversation mode to IC4U2 by using Dialogflow. So with the help of Google Assistant API, the blind person can make conversation with IC4U2. These are some phrases that I thought maybe the blind person would like to ask. I've trained IC4U2 to choose one of these responses randomly. I am also developing this feature so that I can train IC4U2 to respond to more phrases. I must admit that training IC4U2 is a lot easier than training my own dog, Bailey. Now, I would like to show you a video of IC4U2's artificial intelligence abilities. Talk to IC4U.
All right, let's get the test version of IC4U. Woof woof. Hi, my name is IC4U2. I am your guide dog. How can I help you today?
Tell me about yourself, please.
My name is IC4U2. I am powered by Raspberry Pi and Arduino Mega. I was created by Selin Alara Ornek, also known as Celluloid.
Okay, Google. Go. Okay, Google. Stop.
I see a stop sign. I stop for security. There is a chair in our way. Let's go round it.
Okay, Google. Down. I'm currently working on integrating Google Maps API to IC4U2. Right now, I managed to make IC4U2 to pull directions data from the Google Maps and read them out loud to the blind person. I am still working on IC4U2 to follow the directions autonomously. Any recommendations at this stage shall be appreciated. With the help of GPS Shield and Google Maps API, I plan to make it possible for IC4U2 to navigate to the destination that the blind person has chosen on Google Maps. To do this, I also need to improve features on IC4U2. I would like to add sound sensors in order to improve its senses of the surroundings, such as car noises when crossing the road. I would like to change the hot word to OK IC4U, or else it triggers all assistant-powered devices on its way. I would also like to add a LiDAR to support image recognition with dynamic 3D mapping of its surroundings. I believe that when all of these are complete, IC4U2 will behave intelligently disobedient, like a real guide dog with the help of artificial intelligence. IC4U has eyes that are little screens, and I also have plans for IC4U2 to show its feelings through those screens. First thing I would like to do is for it to show hearts when it sees my mom. While working on IC4U2, I also built BB4All, a robot that helps teachers, students, and staff at school. BB4All has face recognition ability, so every morning it greets the children by name and asks how they are. If the student is to say that they are not good that morning, it refers them to one of the teachers. BB4All also helps with any announcements that have to be made. As you all know, teachers love to give homework at the last minute, especially my old teachers. So BB4All is in charge of handing out homework. BB4All will walk around in school. When it sees a student, it will recognize them by their faces, use their name to greet them, and ask them how they are feeling. Depending on the answer, BB4All will take different actions. My next step will be to improve conversations by using Dialogflow. One of the main features of BB4All is to prevent bullying. I have also made a smartwatch for each student to wear. The watch is equipped with a pulse sensor, panic button, and an eye beacon. If the student's heart rate suddenly increases or they press the panic button, the eye beacon sends a signal to the gateway, and BB4All can track the student through the gateways. I believe that as BB4All is equipped with both face recognition and audio recording, this should be quite effective in preventing bullying. Now, I would like to introduce you to BB for All.
Okay, Google. I'm fine, thank you. Great to hear. Hi, Selin. How are you doing? Okay, Google. Not too good. Sorry to hear that. Would you like to talk to someone? Okay, Google. Walk around. Okay, Google. How's the weather like in Istanbul? Currently in Istanbul, it's 17 degrees with showers. Today, there will be scattered showers with a forecast high of 18 and a low of 12. Okay, Google. Can you tell me about the solar system? According to Wikipedia, the solar system is the gravitationally bound planetary system of the Sun and the objects that orbit it either directly or indirectly. Okay, Google.
Hashmet the Android. I first met Android at the Google HQ in Dublin, then at Googleplex. As I really like Android, I decided I want to build an Android robot. Last year, I met Matt Britton during his visit to Istanbul. I asked him if anyone had ever built an Android robot. He said that there were a few, but also said, why don't you build one? So I did. İlker abi from Google named him Hashmet at the GDC DevFest in Turkey last year. I can control Android by my phone. Hashmet also has face recognition. First, it creates a variable with my face image. It puts the variable in a list. In another list, it combines my name and the variable. And if Android recognizes my face, Android gives me a special message. I'm a big fan of Star Wars, so I made Dio from the last Star Wars movie. This was my first robot that had one wheel. I'm still learning, and I learn something new every day. I'd like to thank all my mentors for helping and supporting me. Thank you for listening to me. Please follow me on my social media accounts and don't forget to subscribe to my YouTube channel.
Wow, that's amazing. Selenoid, if that's what we're going with right now. You're happy for people to contact you, people who are interested. I can see in the comments that people are just blown away by the amount of quality work that you've done. What's next on the horizons? Have you anything planned?
I am going to make BB for All into a new version. I'm going to change it with 3D printed parts, and I'm thinking of making a new robot.
I'd be surprised if you weren't. So do you have to get sponsorship? Because I can imagine that these components are not cheap.
Yes, they are not, but I have my dad who does his best to help me.
Well, going beyond for all of our viewers out there, if anybody's interested in getting involved, I'm pretty sure Selin or Selenoid might appreciate some components, parts, or anything else. If we could help her out, that'd be great. We are one community. Thank you very much for being a part of DevFest, Selin. We really appreciate your time, and what you do for developers in general.
Yeah. So Selin, Yeah, I was just going to say, yeah, great talk. Really enjoyed it. Certainly got some amazing experience there. You've used a lot of different technologies and coding languages. Just ask maybe what your favorite bit of technology is, and which one you think is best suited for the type of robotics that you're doing.
I really like when it recognizes something with image recognition, or like when it listens to my commands, and when the technology works after a lot of failing.
All right. That's great. Okay, thanks, Selin.
So we are taking a coffee break just to process all that information. We'll see you at 12:15, and thank you for joining. Don't go. Wait, we are going to have pretty exciting talks later on, so stay tuned. All right, we are back. So in our second block, we're moving towards AR and VR. So we have for our first speaker, Julien Salvi, which is going to talk about please draw me a ship in AR. And our second talk is gonna be Zack Akil from Google, who is going to talk about build and deploy ML models in VR. And the third talk is going to be Jay Patel, who's going to talk about cardiac augmented reality. So what I'm going to do now is that I'm gonna bring my colleague Harris to the stream.
Hey, Ricardo.
Hey, how are you?
I'm good. How are you?
So we are going to bring in Julien. Hi, Julien.
Hi.
How are you?
I'm good, thanks.
How's it going?
For now, all good.
So, Julien, I have a question for you.
Yep.
I seen that you had an experience in VR experiences in cinemas.
Yep.
Yep. So, what's your take? With the current situation, we are in very interesting times for that field.
Oh, yeah, my former colleagues are working on that. I worked maybe 3 years on building a VR theater for Oculus Go, Oculus Quest, and Cardboard. I think it's a good take to watch movies in VR, especially in these times.
Yeah.
Okay. So I'm gonna leave you with your talk, and thank you.
Yeah, thanks. So, hello everyone. I'm Julien Salvi, Android engineer at Innovator, a French startup. So today I'm going to talk about AR and mostly AR Core and SceneForm and how you can draw a ship in AR with these tools. So let's have a look, a bit of overview of augmented reality in Android. So here is the big number. We are almost 1 billion user of AR, so it's a pretty big number. And now it's a good thing to build Android apps with AR. You can reach a mass market. So let's look at what you can build, what kind of app you can build for AR. So first, you mostly can build some app for fun. That's the main thing for AR. But you can also build things for housing or real estate. For example, you can place your sofa or your chair in your living room, or you can build AR apps for gaming and leisure. For example, here the famous Pokemon Go. And there's a lot of use cases where you can use AR for gaming. Or you can use AR for science, education, or industry. So here, for example, you can present the solar system or present a skeleton. It depends on what you want to do. You can learn a lot of things and learn the fun way, for example. And also you can use AR for sports to get a lot of statistics about the game you're watching. For example, to get the stats of a player who in a football game. And also you can use AR for enhance your daily life. For example, here the Google Map AR feature. So it displays the point I want to reach and the path you can take or using your car or by foot. And so for building AR application on Android, you can use IR Core, which is built by Google. You can use Vuforia or Wikitude. And if you like open source things, so you can use AR Toolkit. It's a pretty nice thing, especially if you like open source SDK. If you don't want to go for building your own 3D assets, so for example, with Blender or Maya, you can search in Sketchfab, for example. This is the first one. There is a pretty nice database of 3D assets. Some free and some paid assets, but it's not so expensive, and it's very amazing. This is a large database of 3D assets. Or you can go for Poly. Poly is the 3D database from Google, or TurboSquid, or the Unity Asset Store. They have a lot of 3D assets here, and if you want to go for building your own application with Unity, you can go for it. Now, let's talk a bit more about AR Core and SceneForm. That's our focus today. So AR Core and SceneForm are made by Google. They provide a lot of features such as motion tracking, light estimation, or augmented faces for building fun filters. And also with SceneForm, that's a nice thing. You can bring Android UI in AR, so you can use your layout from your application, and they will be displayed in AR in your AR scenes. And also, IR Core is supported now on 250 devices. That's a lot of devices, so you can target a lot of users when building for IR Core and SceneForms. So now let's take a look at IR Core and SceneForms and see how we can actually build our ship in AR. So we are gonna go for the simple shapes. So here we are will be displayed a box. Well, there is a ship inside the box, and then we'll go for how we can actually build a ship with the form provided by SceneForms. So the basic shapes are cylinder, sphere, and a cube. And then we'll go out. We can add some complex 3D assets in our scene. But first, I want to show you a bit of timeline. So how we end up here with AR Core and SceneForm. So it all started in 2017. The first dev release was in mid 2017, and then at the beginning of 2018, AR Core was released with the 1.1, and then a bit after, SceneForm came in. And at the beginning of 2020, SceneForm became open source with the 1.16, but you can still use the 1.15. Which provide the use of the 8BX and the object format. If you go for the 1.16, you only have to use GLTF assets for your 3D assets. Now we are in AR Core 1.20, and there are still a lot of releases to come in. So, building for AR Core and SceneForm, here are some requirements when you have to build your application. So you have to target the SDK 24 if your application is full AR. Otherwise, you can target 14 if the feature you build for AR is just a small part of your application. It requires OpenGL3. If you want to build for AR Core, the Google Play services for AR must be installed in your device, unless you cannot use AR Core and SceneForm. If you want to build a scene form application with hardcore, it requires Java 8. Also, a bit of math before we get into code. We are beginning for AR. So augmenting reality is like, yeah, as it said, an augmentation of our reality. So we are in a 3D world and we have to do some 3D operation. So we'll get into 3D math sometimes, and we are using the 3D vector, so vector 3 for positioning, for doing some translation, or for some scaling. And also we are using quaternions, which is a mathematical operation for doing some rotation inside of a 3D world. So it takes a four coordinates vector to manage rotation. It's a very nice thing, a very powerful mathematical operation. So if you want to dig into that, feel free. It's good for the future. And we are using the right-handed coordinates, like the Opal-GN convention. So it's the x-axis, y-axis, and the z-axis. Here are the basic shapes provided by SceneForm. So you can build without any pain a cube, a cylinder, or sphere. And all of that thanks to the shape factory. And so when you are building these shapes, you must provide a center or radius or a size, depends on what you want to build. And every shape you build accepts a material. And what's a material? So material can be, for example, a color, plain color, for example, red, blue, or purple. And also it accepts some transparent color and texture. So with texture, you can come with some close to the reality texture. So here, for example, we are using some cardboard texture for the box. And the material is generated by the material factory. Then this material will be attached to your shape. So here a bit of code, for example, here. I loaded my my texture. Then once the texture is loaded, I build the shape, and then I inject my material to the shape factory to build actually my box that will be displayed on the scene. And here for the little example with my AR fragment, once the shape is built, just need to tap on the scene, and the renderable will be added to the main scene. Now you have the basics of SceneForm, so you know how to build shapes, and now we'll see how you can add a lot of shapes and combine them to have a more realistic shape in your scene. So think your scene is always a graph. Think as a graph. So we have different node. You have your main node, and then you have all your nodes you can add. For example, here we have to provide a sheep. So sheeps will have several parts, and a node can have several children. And a node represents a transformation within the graph scene. So nodes can have one parent and have 0 to n children. So let's take a look how our sheep is looking as a graph. So here's a representation, a graph representation of our sheep. So we've at the head with 2 ears, which are 3 cylinders. The 4 legs will be here with cylinders, and all of the body parts will be spheres. So that's our sheep is represented as a graph, as a SIM-form graph. So on top of that ship, we can add some very nice Android UI. So here I'm going to add a card with some text and images, and I also added a checkbox. So with SIM-form, you can add all the Android UI components you want. So list, card, text view, images is as usual when you are building your own Android app, your classic Android apps. So build your XML layout, and then you can inject this layout in AR, and it will be rendered as it is in your Android app. And also all the interaction are working as usual. So if you want to set an unclick listener or not uncheck listener for the checkbox, it's working as usual. So here's a bit of code of how you can add the ship card inside your node. So it's going to build a view renderable with your layout. You can set the positions of where you want to display the card. It will build the renderable, and then you can bind the views from the renderable. So display the text you want, the images, set the listener. And then you can also add some animator. So you definitely can do some crazy animation here with SIM-form, because you are in the air and you want things moving around like in the real world. So you can play with position, scaling, or rotation. And if you are familiar with Android development, you can use object animators for animating nodes. And to compose an animation, for example, a composition of position, scaling, or rotation, you can use the animation set, which is provided by the Android SDK. So here we are going to create an embedding animation. So it's a combination of rotation and translation of the head. So for building this kind of animation, we have our local rotation here. So we are using an object animator for rotating the head. And then we are using another object animator, the local position for the head, for moving from the top to bottom, and then we can repeat this animation. So all together, we have our animation set. We're using the quaternion for doing the rotation. And then we can play together to have a really nice headwing animation. I will show you the headwing animation in just a few minutes. But first, I want to talk a bit about how you can add your complex 3D assets on the scene. So if you want to use some very complex 3D assets, go for the GLTF format. It's very optimized, especially for mobile, and it's very now a powerful 3D format. Object animator can still be used with the 3D assets. So if you want to add some nice animation on it, you can still use it. Or if the GLTF assets as animations on the assets, you can load this animation thanks to Filament. That's a library built by Google. And so here's a sample code of how you can download and display GLTF assets. So you can download your assets online, or you can have your assets locally on your application. It's pretty similar to build shapes, for example. And here is a code snippet of playing the animations for GLTF or for FBA format if you are using Synform 1.15. And for 1.16, it's very simple to play the 3D animation. So let's have a look at our ship. So here is our sample application. We have some fun denting chip here. First I want to show the boxes we built before. Here I can add a red box here, so I can scale it. I can move it on the scene. I can build another box with our cardboard texture. Can move it around, can use the rotation. So this is the basic shapes using Synforms. And here are the sheep here. So placing the sheep on the scene. So here is the sheep in my living room. So if I click on it, so I can display the card above the sheep, and then I can trigger the headbanging animation. So it's also moving forward and backward with the headbang animation. All right, so now we have learned how to build a ship in AR. Let's take a look at all the nice features AR provides. So there is augmented images, so you can bring some images to life. So you can use some markers. You can use up to 1,000 images to animate and add some very nice AR stuff. So you can really bring your images to life. And it's a very nice thing, especially maybe for museum or some presentation. Also, you can use augmented faces. This is like mostly for fun, for building your own filter like Snapchat or Messenger. It uses face recognition. Your face will be mapped into a 3D mesh, so you can add some nice things drawn like a fox ears or maybe like Viking hats on your forehead, on your nose. So do something crazy and play with it. It's just for fun here. This is one of my favorite feature. This is a cloud anchor. So this is here really to build and create collaborative AR experience. It's mostly for multiplayer AR games or experience. So your data, the data of a 3D object will be shared across the users. So for example, you can play a ping pong game with a friend. The data of the table will be shared between the users, and also the ball data will be shared. It's going to be like a great experience as you will be playing a ping pong game in the real world. And for sharing the data, you can use Firebase or your own solution. Depends of your need, but you can go for Firebase. One other feature which is very nice is the TEF API. Here you can add more realism to your scene, so you will have an accurate mapping of your scene. So you can place your object behind a real object, and it won't be rendered if the 3D object is hidden, for example, behind a box or behind a chair or behind anything. It's in the real reality. So it's mostly about controlling object occlusion and be always more and more realistic. And to be always more realistic, we also need some lighting estimation. So it's another feature provided by AirCore. It will provide some details about the lighting in your scene. So it will use the light estimation of this of the room you are, or of the sun if you are outside. So it's very easy to enable immersive and realistic experience. There's two lighting modes here available: the environmental HDR and the ambient intensity. Depends of what you want to display and the realism you want to add to your scene. If you want to know more about AirCore, take a look at the documentation. It's very good. And also take a look at the code labs provided by Google. It's very interesting, and they provide some recent code labs about the depth API, and it's very fun to take a look at it. If you want to know more about some design guidelines for AR, go for the documentation provided by Google. It's very good. If you want to dig a little bit about the AR ship I showed you, the code is available on my GitHub, so feel free to fork it, to download it, and to take a look at it. It's free. And thank you very much for listening me. If you have any question on building nice AR application with AirCore and SceneForms, feel free to ask.
That was very cool.
Perfect. Thanks, Julien. Really appreciate that.
Thank you.
So our next speaker is Zack, Akil, and he's a guy that is very enthusiastic about machine learning and VR and ML and webcams and Oculus, Google Cloud, AutoML, everything. So, hi, Zack. How are you?
Hello. I'm doing really, really good. I'm very excited. How have you been?
Good, very good.
Great.
How is your basketball skills going?
Oh yeah. So I built a project to do with analyzing my basketball skills. Well, the result of the project was that I wasn't very good at basketball, so I just kind of got bored and shifted to other things. I'm now pivoted to cycling and the piano.
Oh wow, cool.
Nice.
And VR, obviously.
And yes, VR. Yeah, VR is the new thing.
I have a more serious question for you. What's your take on GPT-3 in general?
Oh, is that the text model?
Yep.
So I like to specialize in. I like to just play around with images and video. But my colleague and friend Dale, she specializes in everything language, and I just default to her for any opinions on this. And she put up a really good and nicely controversial sort of post on LinkedIn about the GP3 model, and how like it might be just memorizing stuff. So it's kind of like, it's really cool what it does, and then don't get too excited about if it's really understanding stuff. But again, I'm just defaulting to her for the opinions because I have no clue what's going on with it. I'm just all about images and video.
Cool. So we'll talk to you later after your talk. So
I'm
thank
super
you.
excited.
Oh, but I would during this talk, I've got quite a an interesting AV setup on my side. As you might have guessed, there's probably going to be some live VR demos. So one of you need to be ready to come in. I kind of like need who are they called? They're called like the sort of guy in the control panel of the Matrix to just let me know if I'm there or not. So I'm going to be calling one of you guys during the talk. So be ready for that.
Okay, cool. Don't worry. We are going to jump and help. Cool.
Okay, awesome. Cool. Let's get started. So hello, everyone. Thank you all who have joined for this. This is going to be a bit of a quirky talk about one of the things that I've built recently during my time in lockdown. It's all about virtual reality and machine learning. Bit of background on some of the previous things I've built, because it'll give a bit of insight as to what's probably going to be shown today, is I love everything to do with physical machine learning. I got my start into programming with Arduinos. So like it's like a credit card sized sort of mini computer. And then from that, like Raspberry Pis and stuff. But with Arduinos, it was really satisfying to like write one line of code or a couple of lines of code and then have like an LED flash on and off. Because it's one of these platforms you can just plug in any kind of components and you can just write the raw sort of code to like make it like voltage versus ground and all that kind of stuff. So yeah, I got started with that when I was young. And then ever since then, anytime I learn something new in tech, I see if I can apply it to like a physical demo because it's the most rewarding for me. And an example of a recent, well, not too recent, it was a couple of years ago, of a physical ML project. Because after I started learning machine learning, naturally, I'm like, oh, how can I apply this to something physical and make it more interesting for me? And this is an example. This is a physical neural network visualizer. So I built this using Raspberry Pi, an Arduino. And if you're familiar with scikit-learn, the open source machine learning Python package, I actually have this in the background. Scikit-learn is training a neural network model. And then because it's all Python and the Raspberry Pi is all Python, I have it sending the sort of internal weights of the neural network directly to this Raspberry Pi that's empowering these LEDs. And yeah, it's a way so like as it's training in real time, you can see the kind of internal state of the neural network. So all the lights are directly reflecting of the neural network as it's learning. So you might be thinking, it's like, well, how can you use this? And that's a great question. Not one I'm most concerned about. I just kind of built it because it was fun and it looked interesting. And it's kind of the same pattern I take with most of my things. You know, the practical aspect comes later, but the cool bit comes first. So cool first design. Here's another one. This one actually was a bit more practical, but still cool. This is applying real-time machine vision running locally on a Raspberry Pi device. And the idea with this project is to give cycling in London specifically, because I live in London and I cycle everywhere. I wanted to give myself a bit of spidey sense. So I wanted to know what was happening behind me without me having to turn my head or like install an ugly mirror thing. And I kind of came on this kind of solution. And it's actually using, I've got one here. It's using this device, which is an edge TPU that Google makes. And it's a way to run sort of advanced machine learning models, but it's super low latency on devices like the Raspberry Pi. So I plug this into a Raspberry Pi, and then the Raspberry Pi will go from making like 1 or 2 predictions a second to 30 or 60 predictions a second. So it's really, really cool for real-time machine learning applications. And because this one is all about like, okay, tell me if there's a dangerous truck behind me versus a car or a cyclist, and I wanted to know that instantly, the TPU is like perfect for this kind of application. And some of the things I'm going to be talking about later on this talk, they kind of tie back to the TPU because it all kind of ties together with AutoML in the cloud and stuff like that. So yeah, so that's another example of a fun project. And I'm continuing working on this project. So if you're interested in seeing what the future of this project looks like, feel free to follow me at the Twitter handle. And here's the last thing I'll show. Hopefully this will show here. So this is one of the first things they ever built. And this is using AutoML in the cloud. And again, Raspberry Pi physical. So this is a physical nutritionalist that will live on your desk. And what I did here is I Google searched junk food images, Google searched healthy food images, threw those into a tool we have called Cloud AutoML. And it would automatically train a model without me having to write any code. And then it automatically presents like a sort of API endpoint that I can then call from any sort of internet connected device. So I use the Raspberry Pi just to take the photo, and then no machine learning happening on the Raspberry Pi. All it's doing is sending the image to the cloud endpoint to then get a prediction back from it and make its decision in the real world. So yeah, I love AutoML. I love things. I love the sort of physical applications around it. And this is where I go here. So since lockdown, building physical demos isn't as sort of applicable. It's not as convenient anymore. And when I go to present them, it's not as fun. So here's my take on that. Let's move my physical demos into virtual demos using virtual reality. And I know a couple of people have got a few of these. So I've got this. I got this recently. This is an Oculus Quest. And what's very interesting about this is it happens to just be an Android device under the hood. So there's some really cool things you can do with that knowledge. And I'm going to be teasing that out later on. So let's get on to what I'm doing, what I'm showing off today. And the first thing we need to look at is the problem we're going to be solving. So today we have this company, this made up company, but it is still a company. And specifically, it's called Hindcycle, and they are experts in hindsight. They're going to be digging up landfill because it wasn't a good idea just to bury everything in one place. We need to dig it up and recycle it properly. So they have this sort of scalable problem that they want to solve. We're going to try to solve it, and I'm going to try to demo it in virtual reality. So what are they actually going to try to do? Yeah, it's a sorting problem. It's given a big stream of unsorted rubbish. It needs to be correctly sorted. And we're going to be using a visual model to do this. And it's great to talk about it, but let's actually show it. So here's where this talk could go off the rails. I'm going to request one of my MCs to come back because we may encounter some technical difficulties. So what I'm going to do now is I'm going to put on this headset. You won't be able to see anything yet, but thank you for coming back to help me with this. Okay, so I'm going to, in this, it has a pretty neat feature where I can share to a Chromecast device, which doesn't sound immediately useful right now, but what I've also got on my side is a ridiculous setup, which goes from Chromecast device to USB HDMI capture to OBS pretending to be a webcam. And what I'm going to do now is to overlay the VR into my webcam. So I'm going to request that my face get put on full screen by the magic of the coordinators. Am I able to get my face on the full screen?
Yeah, give it a sec.
Oh, getting close. Oh.
I have no idea how we can get it to them.
Oh. Hey. All right. So, welcome to Hindsight Factory. Let's get started. So I'm going to recenter myself. Here we go. All right, I'm going to come over here. Let's look at the problem as it is. So the moment we're going to try to solve this, and we're going to try to solve it manually. Just going to quickly check under the glasses. Yeah, okay, so we got apple, organic matter. That needs to go there. We get a score of 1. Nice. Oh, glass bottle. I believe glass is 2. Nice. Oh, apple's almost out. Okay, look at this. Who takes 1 bite? So wasteful. Okay, so we're doing pretty good. We're getting forward. Yeah, you can see we're probably going to need to hire. Oh, now that as they're falling off, I'm losing points. That's not good. Oh, and as we scale up, this is going to be tricky. Okay, I've got plastic. Okay, this isn't going well. This is not going to look good on my performance review. Okay, I want to solve this now. I want to use machine learning. How do we do that? Well, first we need to collect some data. So let's get up a data collection device. Here we go. So what we have here is a little virtual camera that is looking down onto this kind of area of the thing. And you can actually see my hand following this. So it's going to be taking constantly photos. And these are the photos we're going to use to train our machine learning model. And the idea is that after we train our machine learning model, we'll be able to potentially run it on this conveyor belt to automatically classify the items on the conveyor belt. Once we can classify them, we can then say, like, find out where they are on the conveyor belt and automatically, like, get a robot arm to put them in the right place and see, oh, this is terrible. This is just, oh, I didn't even put in the right one. Okay. So that's the problem. Let's jump out of virtual reality and let's change this back. I'm going to fix my VR here. We're going to go here, go there, back to the slides. Cool. All right. So now that we've seen the problem, how are we going to solve it? Well, we will come over to Cloud AutoML. So those images that were being taken in the sort of VR conveyor belt, what you're able to do, if you're not familiar, so this is the Google Cloud platform, and what we're looking at now is just Google Cloud storage. So this is a kind of like production grade Google Drive for applications. So I'm able to just upload any kind of objects here. So here's an image. Let's look at this one. So here's an image. Okay, so that's one of the images. I've uploaded, I think, maybe 100 or 200 images into Google Cloud storage. And once those images are uploaded into storage, we can import them into AutoML. So AutoML is here. So if you're looking for where it is, it's under the Vision tab. And then this will have our AutoML. In fact, let's navigate, because then you can see. So there's where AutoML is. Get started. I use this quite a lot. So I've got a few models already here, but I'm going to look at my recycling one. And what I did is I imported these images, and then built into the tool, there's an interface to allow you to draw the bounding boxes. So I've went through like 100 images, and I drew a bounding box around the things. So this is the process of labeling our data. So it's nice that I don't need to do anything like before I upload data. I can just upload unlabeled data, so data without these boxes, and then in the UI actually draw the boxes. So maybe if there was something here, I can draw a box there and say, okay, that is a glass and metal. And I can add more labels. If I want to say add a new category, I can do that right here in the UI. So that's cool. That's the interface of uploading the images to AutoML and then labeling the images in AutoML. There's also features to use a labeling service that we have, so that you don't need to, if you've got thousands and thousands of images, you can just write a PDF that will be read by a human and then be given to other humans to actually label your data for you. So there's multiple ways of getting labeled data into AutoML. But that is effectively the trickiest bit of AutoML, is getting the data in and making sure the labels are there. And what's nice is we can actually inspect and see, okay, all these labels look good. We have a couple images, and we can see kind of a mini breakdown. Hopefully that's visible. A mini breakdown of, okay, I've got 196 labeled images. Cool. And here's how many sort of labels for each of these categories I have. So I've got, okay, 106 boxes of glass and metal, 160 organic. Okay, that's good. That's good. Let's train a model. So we go to the train tab, and I've already trained a model, but I can show if I was to train another one. Here is the interface, and this is really cool. So in AutoML, we can train a model to either be hosted in the cloud, or, and this is going to be really good for our application, train a model that's then going to be downloaded and hosted on the edge. So in our factory setting, my specific factory, I care a lot about latency. Like I want to make sure, because I'm making predictions, like multiple predictions every second. So I'm going to want to run my model on the edge to cut out the sort of overhead of sending a web request. And so that's why I want to use an edge model. There might be other reasons why you want to use an edge model. Like, for example, maybe your application is a remote application somewhere where there's no internet access. And that way, like a cloud hosted model won't suffice. or maybe you've got super strict security concerns where you don't want to send any images over the internet at all, then an edge model is really good, because then you can just have the model hosted locally, and then users don't need to be concerned about sending images over the internet. So yeah, there's a couple ones. So you got latency, security, and those are the two: latency and security. Yeah. Oh, and remote, not internet access. So I've got some of those concerns. So I'm going to train an edge model, and then we can say, okay, our edge model, when we train it, do we want it to be super fast, or do we want it to be linearly more accurate? In this case, I don't have major concerns about accuracy over latency, so I'm just going to choose the middle one. And then what you'll do is you'll say, okay, how long do you want this to train for? This is all going to be trained in the cloud, so you don't need to have anything installed. And after it's done training, it will send you an email saying, okay, we finished training your model. You can come and you can download it. Or, and you'll see it, I'll show a demo of this as well. You can just take that model that was trained for the edge and still host it in the cloud. And this is really useful for like debugging your model or just testing it. And you'll see, I'm going to test my model. So I won't bother training another one because I've already got one trained. And after I've got one trained, we can evaluate it. So this is where we can actually look at the performance of our model and see if it's right for our application. So I can see here, if you're used to training machine learning models, some of these metrics you may be familiar with, like precision and recall. But some ones that are a bit more intuitive are things like, if I click on an individual class, like glass and metal, how well does it perform on this specific class? It will walk you through like, okay, given the data that you gave AutoML, so given all that labeled data, AutoML will automatically take out a portion of that data to be its test data. So it won't actually train with that data. It will save that data for when it wants to kind of analyze its own performance and say, okay, how well did I do given these images that I've never seen before? So here's how well it did on those images. So true positive, this is where it correctly predicted glass and metal, where it should have predicted glass and metal. And then we can see false negatives. So this is when this bit always gets me confused. False negatives, when it incorrectly said it wasn't, and there's none of those, so that's good. False positives. This one's very interesting because when I sort of labeled the data in the UI, I didn't bother labeling the ones that were near the edge of the image because I assumed like, as a human, I wouldn't care too much if they're near the edge. Wait until they're in the middle of the image, and then I want to predict with confidence. But so I didn't actually add labels to those ones in the edge. However, in the test data, it found images with glass and metal on the edge of the image, and it correctly predicted it to be glass or metal. But I happened to not label it glass and metal. But now it's being very hard on itself. It's saying, oh, I did this wrong because I falsely predicted there to be glass and metal here. When in actual fact, I was the one who was wrong in this case because I didn't label it properly. So normally, if you're not visualizing your kind of performance metric, this might slip under the radar. You might be like, okay, our model's 98% accurate. That's fine. We'll deal with that. But in this instance, our model was 100% accurate because even when I mislabeled the data, it still got it correct. And it's just a really cool way of visualizing these kind of errors, because then you can use this to feed back into like how you say label the new data. You'd be like, oh, actually, no, it performs well near the edge of the image. Let's label those properly. And we can get a kind of more representative score, or we can add more labels, or we can see like where the model's going wrong. Let's add more images around that category. So yeah, it's a really, really cool way of visualizing performance of a model, and it's all built in and you're kind of given it. And every single time when I sit on this page for too long, it crashes. So right on cue, we're gonna exit out of that because there's one last tab that I want to show, which is the test and predict tab. So I'm going to go back into AutoML, back into the recycling. And I'm going to, we've already looked at the evaluate tab and test and use. So I've got our model, and right here, I can deploy it and run it in the cloud. And why this is really cool to do, because then I can straight up just test it with some images. So I can upload an image directly into this UI and see, oh yeah, both organic, that looks good. Let's upload some more. Let's just upload all of them. We can upload multiple, I think. Yeah. Yeah, that looks good. All looking good there. Glass, metal, plastic, glass and metal. That's glass. Yeah, that's glass. That's glass and metal. That is a plastic bottle, I believe. Yes. There's some organic. Look at wasteful. That's awesome. So now I can test it. It's really cool. Not only can you test it, that's effectively in production now. There is a full endpoint that you can ping with the Surface account and stuff and tie it into pipelines. And yeah, that's effectively the whole pipeline of getting a model into production in the cloud. But we want to put our model into production on the edge. So how do we do that? Well, after it's done, you can come down to the bottom page and you can say how you want to use your model. If it's for the edge, click on this, and I believe it will, say where do you want it to export the model into cloud storage, and then it will create a TensorFlow-like model that you can then deploy anywhere. This can be Android, it could be Raspberry Pis, it could be other computers. TensorFlow-like is a really nice sort of widely used model type for local machine learning. So it's really nice that it just allows you to export into this type. And if you want to learn more about this, I've went to the cloud, I've shown that. TensorFlow on the edge. So my teammate, Dale, she made an incredible video to show you how you can build a machine learning model in 10 minutes using TensorFlow Lite and TensorFlow JS. It's not using AutoML. It's instead using this platform that Google made called Teachable Machine. So I can actually show a bit about this. So this is Teachable Machine. This is kind of the same interface as AutoML, whereby you upload images and it just takes care of the training itself. Like it will just train the model. The difference between when to use Teachable Machine versus when to use AutoML. Teachable Machine doesn't do anything in the way of, and I'll explain what these are, transfer learning and like data augmentation. And also Teachable Machine does all the training in your web browser, like your very Chrome sort of instance of the web browser. So it doesn't scale well for large data sets. AutoML, on the other hand, all the training is done in the cloud. So it scales to like hundreds of thousands of images. And it does a lot of extra stuff in terms of automating data augmentation. That's something where you can take one image and you can rotate it and stuff and change the color to get kind of multiple images examples to make a more robust model. And things like automated hyperparameter tuning. So it does a lot of really advanced stuff automatically for you. So it's a bit more production grade and scalable. So that's the difference. But Teachable Machine is amazing for like quickly prototyping. And I highly recommend it. And I highly recommend Dale's video on how it works. Specifically, for my application, I'm deploying this TensorFlow Lite model into Unity. And there's a little bit about how you can do that in Unity. I've got links at the end of the talk, but I want to quickly, before I run out of time, let's go back to the factory. So if we remember the weird setup we used, I'm going to be going back into here. I'm going to be resharing or recasting this. All right. So I'm recasting, and then I will 3, 2, 1. Here we go. All right. Okay. So we're hopefully back into the factory. We can see, our productivity is not looking too good. We are still in the process of scaling. Yep. And that's going to continue going down. So how do we fix this? Well, we're going to go, backwards. We're going to go to the cloud this way. Okay, over here we have computer. We should get a familiar looking interface. So this is my AutoML dataset. I've already went through and labeled all of the images. I can inspect. Yep, this looks like a good binding box here. And yep, these labels all look good. So this is really, really good. We're going to go to trainer model. We get a little breakdown of how many labels of each category, and that all looks fine. Trainer model, definitely want to make sure we do our edge model like we discussed. We want to deploy this into that actual factory. So we want this edge and just a middle one. Don't mind too much about accuracy over latency. And we're going to click train. Okay. So while that's training, actually, let me recenter over here. While that's training, it will pop out. There we go. After it's done training, we get our, oh no, it's under the table. I've miscalculated. Oh, here we go. Okay. Here we go. Come here. There we go. All right. Building games is hard. So this is our TensorFlow Lite model. It actually comes out at around 5 or 4 megabytes. So this size of USB stick is kind of ridiculous, but it'll do fine. We'll deploy it here. And here we go. So this is now running TensorFlow Lite on the edge. This will start, here we go. We're starting to crawl back our productivity. What's actually happening here? And I'll quickly have a peek at the time. Doing great. What's actually happening here is, so this virtual camera is taking a photo of the assembly line. It's drawing it to this, in this game, it's a canvas object. So it's drawing it to this sort of canvas screen. And then that very image is being fed through the TensorFlow Lite interpreter that has our TensorFlow Lite model that we trained in AutoML deployed in it. So although this is all happening in a game, and if anyone's familiar with game engines, this one is Unity. And by all means, inside a game engine, I can, if it lets me grab them before it grabs it. Oh, there's some down here. So in a game engine, this object is being rendered, and the game engine is completely aware of that this is a chicken drumstick and it's at these coordinates. So by all means, this kind of demo could be kind of faked with just game engine logic and just figuring out where the items are. But I can go on the record and saying that is not happening here. Legitimately, TensorFlow Lite is running real time on the Oculus. So this is all happening on this standalone device, which is effectively just an Android phone. And it's the model that was trained in AutoML, and it's running at about, I don't know what frame rate I've got it set at here, maybe like 3 or 4 predictions every second of that model that was trained in the cloud. And it's virtually perfect in making its predictions. Although it hasn't never seen my hand before. And when I put my hand in the thing, you see it tries to like grab my hand sometimes. I don't know what it's trying to thinks my hand is. Maybe it's like organic matter. That would be kind of cool. But to be fair, it's never seen my hand, so it's just interesting to see that it thinks it's something. But yeah, that is it. So we've got, yeah, it's all running here locally. And in fact, it's kind of cooler than local because it's literally just running on my face. And that concludes that portion of that. To sum up, hopefully, if we can go back to the slides. To sum up, hopefully I've shown you the full pipeline of how you can use AutoML vision to do powerful training all in the cloud, and then based on your applications, either deploy to the cloud or to the edge to get like super low latency or extra privacy and things like that. So with that, I thank you very much. Here's some links to docs about AutoML. And then for this specific application where I'm deploying TensorFlow models to run in a Unity game engine, one bit of friction that I encountered was just getting this TensorFlow Lite Unity bit of the in the TensorFlow GitHub. They have some experimental thing for how to get it to work in Unity, and it goes through how to build or compile your own version of the TensorFlow Lite interpreter and stuff. And that bit was a bit of a pain for me. So in my GitHub repo that I've got linked, I have it pre-compiled. So if you're interested in actually doing this and running TensorFlow Lite in Unity, I have a pre-compiled library that you can just drag and drop in, and it should just work if you're deploying to the Oculus. So that's the GitHub link there. And I'm in the future for this kind of project, I'm kind of shifting my focus to a smart bicycle. Oh, let me put my face back in full. I'm shifting my focus at the moment for TPU and smart bicycle stuff. So feel free to follow me on Twitter to hear more about that as well. So thank you very much.
That was so cool.
Thank you.
Can I ask you a question regarding the Edge device that you have?
Yes, absolutely.
Yeah. What model is that? What model is it?
What model of the bike? Or because model is like an overloaded term. Is it the model of the bike or the model of the machine learning?
The model of the TPU Edge device.
Oh yes. Okay, this. So this is the Coral USB accelerator. In fact, let me show it here. So it's the Coral USB accelerator. I think that's how you spell it. Here it is, Coral AI. So these are the ones, product. Boom. Coral USB accelerator. So it literally plugs into the USB of the Raspberry Pi, and there's loads of example code for how to, and they've got loads of pre-trained models. So the first version of my bike that I showed at the start of my talk, that was classifying the cars just based on a model that they had on their website. So I didn't even do any model training at all. I just copied their example code and then just scraped out the labels for traffic related things. So yeah, it's a USB accelerator.
Cool. Thank you.
Thank you so much. Take it easy.
Our next speaker is gonna be on the same AR VR trend, and is Jay Patel. Hello.
Hello. Hello.
How are you?
How are you?
How are you doing?
All
How-
good, man. How are you?
All good.
How are you guys?
Good.
Cool. So
Yeah,
we are
let's
going- let's get started.
yeah, so let me share my screen. I think you can you see my screen? Yeah. Now?
Yes, we can see your screen.
Okay. So can I go? Can I start? Is everything fine?
Yes, you can. Just click on present.
Oh yeah, sure. So yeah, hello, good afternoon, everyone from Manchester. My name is Jay Patel. So I'm a software engineer and now I'm currently studying data analytics at Manchester. University is Manchester Metropolitan University. I'm currently working for an accounting firm called as Beavers and Struthers. So yeah, that's pretty much it about my introduction. So let's get started. So cardiac AR. So this was a project that me and my friend Rahul Karikal built in our engineering days. So this was our final year engineering project. So people like if audience is not familiar with AR and VR, so AR stands for augmented reality. Let me just give me some context around AR and VR. So like people get familiar with it. So what is augmented reality, aka AR? So as you can see in this picture over there, me with an headset, it basically take me to the different dimension of the world that has been created. And my friend Rahul, which you can see that he's pointing toward the heart, which is like created in an live environment. So 3D objects are being positioned in and superimposed somewhere in the real world environment. So yeah, that's pretty much context of augmented reality. So let's get, if I can share, give you an, if I can share my screen and pop up. Can you see my screen? Yeah. So if I
Yes, we can.
open an application, so I'm opening up my application, and this is where I have superimposed a skeleton of an. So if you can see, like, yeah, can you see the heart rate and the skeleton? Yeah. So this is the 3D object we have built, and it's been superimposed on this paper. You can superimpose it on like anything, any object you want. So yeah, let me get back to my slides. So cardiac AR is basically an heart rate monitor application, but we have introduced augmented reality into it to make it more interesting. Yeah, so it's been divided into 3 parts. I will talk it in details about the 3 parts: the hard graphics. You saw the demo that I showed you earlier, the APK, and the IoT part. So talking about the hard graphics, so we have designed it on Unity 3D. you can easily get the 3D object easily on the template on the Unity, but it costs you so much. So if you design it on your own, it will be easier and it is cost efficient too. Part 2 is about the APK. So Unity 3D has this feature like you can save the project in .apk file, and you don't have to go to Android Studio. Of course, if you want to customize it on your own, then you can go to the Android Studio and customize and give your own touch. But Unity saves the project into .apk file, so you can do it like that's a great part about Unity 3D. So yeah, and third part is about IoT. So there is a proper IoT chip for augmented reality projects called particle photon. So you will need an particle photon to build an augmented reality projects, and we have used a simple basic heart rate monitor which enables us to calculate heart rate of a person. So now I will show you the demo, a proper working demo. Yeah.
Hi, Jay. You have to share, checking the audio when you're doing the sharing.
So
you
where
can
will I?
you can stop sharing and then reshare, but make sure to use to check the audio.
Okay. Should I stop sharing?
Mm-hmm. And then try to share again and make sure to check the audio.
This one is which one? Yes.
There is a section there in which you have to check the audio, share the audio as well.
I can see a screen sharing tips and just 3 steps. Let's try again. Can you hear the noise?
No, I don't see it. So when you share the whatever you're trying to share, there is a check mark that is disabled by default, and then you have to.
I can walk you through it, like if that's.
Or you can describe it as well. Without you can share the video and then describe if you
sure.
have the.
Okay.
Okay.
Sorry for that. Video is loading up.
That's totally fine. We are live.
Yeah.
Try to
Video
reload.
is not playing.
Try reloading, maybe.
Yeah. Mhm. Oh God.
Hey Jay, is it worth trying Safari to see if it works?
Sorry.
Could you try Safari to
Yeah.
play
Oh
the
yeah.
video,
Okay.
like copy and paste the
Yeah.
link?
Yeah. Sure. Sure.
Yeah, there you go.
Yeah. Can you see?
Yeah.
You can describe what are you doing, if you recall.
So I hope everyone saw that. So yeah, let's get back to the slides. So the main conclusion of this is like if we like combine augmented reality with IoT, it's like mind blowing to be honest. Now just imagine the like we had example of cardiac like of an 3D skeleton and heart rate monitor. Let's just imagine like a carom board, a person playing carom board or something like that. It can be endless, but the cost efficiency like will be so amazing. Like the production cost will be so groundbreaking. So I think so. Yeah. So thank you, and thank you for having me, guys. Thank you, JDG, for having me. So if you have any questions, do let me know.
Thank you, Jay.
Thanks, Jay.
Yeah.
So we are going to have a lunch break, and we will resume at 2:45 p.m. However, I want to share that if you tweet about the event and you are participating for a prize, so just use the DevFest hashtag and DevFest UK UKI, and probably you will be one of the lucky ones. So thank you, and
Thanks, everyone.
I'll see you at 2:45. Cool. So we are back. Thank you for joining us. I'm gonna have some comments here. Remember to tweet about the event for your chance to win a JetBrains license. We have 10 JetBrains licenses available, and we are gonna give away them after, probably before the after party. About the after party, we are going to announce and share the links to that shortly after the last speaker. So please stay tuned. All right. So our next speaker is Matthew Kelly. Matthew Kelly is working in a project that is called Mars Torus. It happens to that project won the Ireland Challenge, which was in the European Space Week in Helsinki last year. So, hi Matthew, how are you?
I'm good. Thank you very much.
So with no more introduction, I'm gonna share your slides and it's all yours.
Okay, great. Thank you very much. Thanks for the introduction. We did win the Irish Challenge in Helsinki, and earlier in this week, on the 14th, we came third in the Space Masters on the OHB Challenge. So that was great as well. We were supposed to go to Berlin, but well, things are a bit different now. And I'll just play briefly, just to get an introduction. Maybe people don't know of Space Masters, but here is a brief video of Dr. Lux. He's introducing us for third prize.
The third place in this year's OHB Challenge goes to Dr. Matthew Kelly and team of Mars Torus with their idea, Mars Torus, continuous lift and navigation in the Mars atmosphere. Congratulations, great idea. And I truly believe one day we will be there, we will be on Mars, and they are contributing to this step with their idea.
Yeah. Yes, so there we had to pretend we knew, we kind of knew a few days beforehand. All right, so I'll get right into Torus and what is it and what does it do and why do we need it? So I kind of looked at the communications that are currently on Mars. So you would have the long-range satellites that go around Mars at a distance of 400 kilometers. You have the Mars Reconnaissance Orbiter, which can take really good photographs from a long distance away, can see vast areas of Mars, but the resolution, although very good, isn't brilliant. So if you can see there in the top right-hand corner, that's a photograph from the Mars Reconnaissance Orbiter of a rover, and you can hardly make out anything because the resolution is so small. So what I was thinking about for future Mars missions, we really need to know a good landing place, a safe landing place. And with that resolution, we can't really get the data we need. And also, there will be a lot of mining going on, and so it'd be helpful to know exactly where the areas of good mining are. So if you kind of look at the bottom, you have the Mars rover there, which is on Mars as well. These have a low resolution camera, but because they're on the surface, you can see every pebble and every rock, and it's very good. But it moves really, really slowly. Over its lifetime, it might get 40 or 50 miles. So there was a gap, I noticed, in between these two methods of collecting data on Mars. And that's when I looked at Torus. So I designed Torus to stay at a height about 2 kilometers. And it can move around like a drone. So it's kind of like a Zeppelin and a drone together. And it can move around the planet to take very high resolution images of different areas. And it can move around the planet if it needs to. So it wouldn't be as slow as the rover, but it would have very good image resolution. So to help to find future Mars landing places, and also it will sample the air looking for traces of methane, water. So this is a short little animation. It's just 30 seconds. I'll talk over it a little bit. And this kind of shows how Torus is getting to Mars, what it does, taking images and sending it back to Earth. So here comes through the Mars atmosphere. Parachute opens to slow down, even though the Mars atmosphere is very light. It will inflate as it's going through the atmosphere when it's slowed down, and it will pop up and stay at 2 kilometers. So it won't actually land on the surface. So inside we contain a vacuum. The payload is a camera, and we have a low gain transmitter. I'll go into all these later. So it would take images and then send that back to Earth using the Deep Space Network. And here, of course, we use the station in Ireland, the National Space Centre. We're hoping to upgrade the station so it does become part of the Deep Space Network. So here, any images or data is collected is sent back to Earth. And then you can also create new missions for Torus and upload them again. So take a little step back. So people might be, who aren't used to looking at the night sky, wondering, where is Mars? Is it there? Can we see it? Actually, at the moment, it's probably the best time to see Mars right now. It's very, very close, and it would be the brightest star when you look in the sky. So when you go out at night, you probably see 3 bright stars. You'll see Mars, and then over to the kind of southwest, you'll see Saturn and Jupiter. And the reason why Mars is very bright at the moment is because it's a thing called opposition, which means Mars and Earth are very close to each other. And then the opposite of that is conjunction, when it's on the other side of the sun and it's far away. So it is kind of interesting, because if you have telescope or binoculars, you can actually kind of make out formations on Mars at the moment. It's quite interesting. Yeah. So on Mars, it's a bit smaller than Earth. The length of the year is maybe twice of Earth. The gravity is less. But that doesn't affect Torus. I'll come into that later. The atmosphere is the most interesting thing. It's only 1% of the atmospheric pressure that's on Earth. And that was a big challenge in designing Torus, because it doesn't apply to the same rules as crafts do on Earth. How we get there, because it's so small, the Torus itself is only 14 meters wide. And kind of similar as the InSight mission, where 2 CubeSats went along for a ride with the InSight lander, we can store Torus and its CubeSats. We're going to have CubeSats as well. They can be stored and piggyback on an existing mission to get there. So as it enters Mars and goes through the atmosphere, although the atmosphere is very thin, it will need a parachute, and it will need boosters to slow down to the right speed to safely go through the atmosphere. So as it comes through, you can see the different phases there. It hits the atmosphere. It gets really hot. We put on the parachute, and the covering at the side eject, and the Torus will inflate. And also, we will do a 2-phase movement. It'll inflate and also evacuate. I'll go into that in a bit more detail. So as it's doing that, it also has boosters on the heat shield to slow it down to a safe enough speed. And then when it's about 5 kilometers from the surface, we lose the heat shield, lose the parachute. And Torus will stay in the atmosphere about 2 kilometers height, so it won't actually touch the surface. You might have heard that there is a Mars mission already going on the way to Mars. It should be there in February. And there's a Mars helicopter that they're going to try out. It's the first time something will fly on Mars. And I really looked at this design when looking at Torus. And although a helicopter is a great idea, the problem is because the atmosphere is so thin, the blades on the helicopter have to spin 10 times faster to get the same amount of lift, and therefore it uses an awful lot of energy. So the Mars helicopter will only be able to fly for 90 seconds, and then it takes a day to recharge. So it's it can't go that far from the rover. So what I think they're going to do is they're going to see is it going to work, and also if it does work, they will use it to fly ahead of the rover to find the safest place for it to drive over, and then it'll come back close to it and use Bluetooth to download any imagery back to the rover. Then the rover will use UHF to the Mars Reconnaissance Orbiter, and then X-band back to Earth. That's how it'll communicate. And so in this, they also were using, because I was looking, it was very interesting because they have the same issues I have, because I have to make mine as light as possible. So for instance, to keep their craft warm, usually there would be some radioactive particles in the rovers to create heat and keep the components warm. And here they used CO2 and encapsulate all the electronics to keep them warm, and they have electric heaters around the batteries. So I will be doing the same. When Torus is 2 kilometers above Mars, we're not using propellers, although there is propellers in Torus. How we get lift is we are containing a vacuum, and because the vacuum is lighter than the Mars air around it, it gives it lift. This has a lot of advantages. We could use helium or hydrogen, but the problem is that you probably know with party balloons that eventually the gas will leak out and the balloon will land on the ground. So it might work. You could land on the surface, fill it with helium, you would float up. Eventually the gas would leak out and it would come back down again. And then you don't have another tank of helium to fill it up to get it up again. So it would only be one use. So with the vacuum, we can, it can stay 2 kilometers. I calculated for the size and the volume needed to keep the lift it would give and the weight to keep it at 2 kilometers. So we can go down to the surface by having a valve and letting in some of the Mars air. This reduces the vacuum, reduces the lift, and the craft goes down. If we want to go back up again, there's a small vacuum pump, very slow, and eventually will push out the Martian air, giving us a good vacuum again, and the craft goes back up to 2 kilometers. There are propellers to move it forward. And there might be some wind as well. I'll go into that a bit later. Dust and wind. These are the questions I'm always asked about because people have seen the movie The Martian, and I don't know if you've seen the start of The Martian, but they have this the rocket. They the rocket nearly fell over with the wind, and they weren't able to take off. But in fact, because atmospheric pressure is so low in Mars, although the winds do get to 60, 70 miles per hour, they have little or no physical effect on anything around them. That's almost just enough to push dust around the surface. So wind wouldn't really be an issue. Although at higher altitudes, it might be enough to move Torus. But we can use that to our advantage because we don't have to use the propellers for forward movement. If we do get wind, we can use it and we can get a free ride around the planet, and we can also use that to look more closely at the wind pattern around Mars and how it works. So that wouldn't be an issue. Dust is a problem. The dust on Mars is kind of like talcum powder, and it's clings to everything because of the kind of static cling, like electrostatic cling, kind of like if you open a box and all the bits of white paper stick to your fingers, it's the same thing, electrostatic cling. And if you look at any photograph of the rovers, it just gets everywhere. And their solar panels get covered over, and sometimes you get little dust devils that go through Mars, and they'll either push more dust on the panels or suck some dust off. For Torus, we're going to be 2 kilometers, so the dust might not be such an issue. We're using a dust repellent coating to keep the dust away. And also, as you're looking at it here, these are all solar panels, so I kind of designed it that in case there is more dust on the top, there wouldn't be as much dust on the sides, and with the coating, with the cling, they would, the bigger particles would fall off, and the smaller particles, would beget because of the coating. They wouldn't be attracted to stick so much. So, kind of looking at what it does, when we take images from 2 kilometers, we can use image recognition to look at the current images of Mars to find craters at a low res, and then overlay that with our high resolution imagery to eventually create really good maps of Mars. And this can be used for landing spots, identifying places of interest. And the problem is how to send tourists to a certain location when there's no GPS on Mars. There are satellites going around Mars, but none of them have atomic clocks, so they can't be used for GPS. So we would like to, if we can, along with Torus, send 12 CubeSats. And when these are in place around the planet, this will be just enough to give a rough estimation of where Torus is, and then we can send out waypoint missions from Earth to go to different locations. Say, for instance, that we know where a rover is that isn't responsive. We could send it there, get images of the rover, send it back to NASA, and maybe by looking at the imagery, they can come up with new ideas to kickstart their rover again, or maybe, just to give them all the options they can. Putting GPS around Mars is very tricky. I'm using CubeSats because it worked well on the InSight mission, where 2 CubeSats went after InSight as it landed on the surface here. So you can see that the 2 lines are the 2 CubeSats. So as InSight went down to the planet, it was able to relay back information, and so they were able to know within 8 minutes that the lander successfully got to the surface. And so these 2 CubeSats called Marco A and Marco B, so they went straight past Mars. There's actually a really nice photograph they took of Mars as they were going past. And so once the lander got on the surface, they just kept going, and they're still going off into deep space. So I was thinking, instead of doing this, I would use a thing called aero braking with the CubeSats. So aero braking is where you aim near the planet, and then the gravitational field of the planet, as it swings around, every time it goes near the planet through the atmosphere, it slows down a little bit. So every time it goes around, it slows down, and gets closer to the planet. This process takes 3 to 6 months, but it doesn't take any energy. So with the CubeSats, you might have a gas thruster, but you'd only use that at the very end just to get your GPS into positions around the planet. But aero braking is a good way, although a slow way, to get CubeSats or satellites in position. One of the things we could do, as I said before, is try to go ahead of rovers to find the best place for them to drive to get through, and also to look at current rovers if they have issues, to send back maybe lost landers. So there's more options there to do that. So Mars Torus, so what it really does is it enhances the satellite imagery that's already there. So allowing for better maps, but for planning future missions, so it'll save time and money to find a good safe landing area. We will sample the atmosphere, looking at methane, finding place for water and minerals. And yeah, I think it will open up a lot of areas for science for future study. And yeah, that's me. That's Mars Torus. Short and sweet. So if you have any questions, I'll try and answer them.
That was amazing. I have one question.
Sure.
What is the size of the CubeSat?
Yeah, the CubeSat is about the size of a shoebox.
Oh, wow.
Yeah.
So we're talking 10 centimeters by 10 centimeters.
Yeah.
Kind of.
Yeah. And the CubeSats, you have to be kind of clever with your antenna design. So I should have put up a slide of the CubeSats to use it inside, but they use a very clever design where they had flaps on the side of the box that folded back into a large square, and they did such a way that the signal was focused in the middle, and they're using X-band back to Earth and UHF to their to the inside lander. So yeah, it was just the great work done by the Mark A, Mark B to get those CubeSats to Mars. Was brilliant, really good.
Are you going to participate in the European Space Week this year?
Oh right, I hadn't heard of it, but the one in Helsinki this year. I didn't hear from them, but maybe I should. Yeah, we were there last year, all right, for the European Space Week in Helsinki.
I think it's in December.
Yeah, definitely should. I'll get on to them.
Cool. Thank you.
Great.
Do you have any questions, Paris?
No, it was good. It was a great presentation. Thank you.
All right, great. Thanks very much.
Thank you. Our next speaker is Alex Patterson. He's going to talk about virtual crowd emotion. Hi, Alex.
Hi, how are you guys doing?
Good. How are you?
Doing great.
You're based in Michigan, right?
I am. It's 9 or 10 o'clock now. I tried catching some of the earlier ones. 5 was a little early for me.
Well, I'm gonna bring your slides and your screen, and the stage is all yours.
Okay. Oops. Just 1 second here. I apologize. I lost my other slide here. Okay, are you guys ready to go? I think so. Okay. So my name's Alex Patterson. I'm the founder of codingcat.dev, and we're going to talk a little bit about virtual crowd emotion. There was a talk very similar to this that someone else presented on. I couldn't help but love what was going on. So I had to make something very similar for Firebase. And the premise behind this is to compare Firebase to Amplify and Data Store. However, I'm just going to go through the Firebase today. You can check out the repo. It will have more of the data store items. We're still having a few problems getting that working at the time of this presentation. So first things first, shout out to the Get User Media API. That's where this whole thing kind of begins. And what that's going to do is actually provide us the video that's capable for picking up faces in this. So it's always good to kind of go back and look where the roots are on these different things. Even though we're using TensorFlow, which we'll talk about in a minute, it's good to know, like, when this pops up and you want to use your camera, that is because of this media devices Get User Media. So always got to talk about the browser and how amazing it is. So jumping into TensorFlow.js, basically what TensorFlow is for machine learning. And so if we were to take a look at the TensorFlow.js website here, there's tons of different activities that you can go through to check out what's happening in machine learning within JavaScript. However, if you look at this, there are several models, and I am by no means a machine learning expert. I would call myself a novice at best, but there's a lot of good tutorials on here that you can read through. So basically, when you're looking out here at the models, though, you'll see a lot of cool things like body segmentation, but not necessarily the face detection that we were looking for like emotions. So there's great examples of face detection. See how it has these boxes, but it's not necessarily telling me, are they smiling? Are they happy? Are they sad? And that was kind of what we're looking for when we're doing these online presentations on how it's going. So normally what you would do is react to kind of your crowd that you're talking to, and you would be able to say, oh, they're happy, they're into my talk, or I've got to tweak this or that. And it's really difficult now in 2020 trying to deal with, everyone online.
Sorry, Alex, could you increase the size of the font?
Yeah, absolutely.
Yeah. So
no worries. So as we kind of talk through the TensorFlow side to this a little more, let me bump that one up too. Sorry, I'm not used to the 4K monitor yet. So the face detection side of this is what we're after, but we wanted to dive a little bit further and go to this Git repo. It's called the Face API. It's probably what it's well known from. And this Just Dude who hacks is the person who put the models together for this. So if we take another look at that site, you'll actually end up seeing a lot of different inspiring facial recognition pieces. So here you're seeing where the face is recognized, and it's kind of going through all the different iterations on here. So it's trying to approximate age, it's doing the surprise face, and then it's recognizing who the person is. Also, it has this cool like facial features. So great job walking through all of this, better than I can probably do. So it's got this facial recognition, the face landmark detection, so you can kind of see all the different features of a face. The one that we're actually going to be focusing on in this talk is this expression recognition. So that is what the emphasis of this talk is. Let me jump back. So we are going to implement this using Firebase today, as I said. Firebase, if you haven't heard of it before, oops. It has several different products that kind of are all bundled together. And what we're going to use mainly is the authentication and database side to this, and then hosting for the application. So what I'm going to do now is kind of talk through the authentication piece. When you first hit the application, there's no sign-in requirement for this. You could make the application so that if you wanted to use it within a conference that you already have people logging into, you could easily set that up. But for our demos and for kind of the site that's out there, it's just easier to be able to hit the browser. And then from that, it's going to automatically create an anonymous user. And then once we create that user, we're going to use that to store off any emotions that come through and store those out to Firestore. And then off of that Firestore, we're going to do some triggering as well. So I am going to jump over to the code side of this so that we can start kind of peeling this apart. I like to show a little bit about the actual application first, so it kind of clicks together, and then we'll walk the code through each part. So I do have this running locally. I'm going to bump up the font quite a bit on this. It's a pretty simple application at this point. It just takes one input on this main home screen. And for us, we're going to do GDG, UKI. I probably already have that one, so I'll do 2. So as you can see, this is now the API. And if I were to hit this, it looks a little crazy. So let me bump down the font a little bit here. So it's already starting to pick up on my different, the different features on my face and understand if I'm neutral or happy, which it's got a different camera view than you guys. So let's try that. There we go. So there's happy, sad, surprise. So those are all the different views. And as it's doing it, it's actually collecting my user that I'm logged into. And it's kind of putting this number to what's going on. The reason that all of these can be used, the idea is that if you're in a large room and you have many people, it will actually pick up several individuals as well. So I have a picture from this weekend, just a fun group of us. And if I just hold this up for a second, if I can get this right, I might have to switch cameras. Hang on one sec. There, let's try it over here. So it'll start to see all the different individuals on there. And it's actually going to ship over an array of people in the room. So you'll see the happy and neutral and things like that start to really ramp up over here. So there are some limitations, and we'll talk through those on Firestore as well. And it's probably not the best setup at this point, but we'll keep carving that out. Keep going. So here's the application, and just to break down the structure, if you're not used to Angular, this source folder is where all the Angular items are going to be. There's several Firebase files within here. And then there's functions, which are actual cloud functions out on Firebase as well. And I'll talk through each part of kind of what's going on here as we go along. So within the application, if you're not used to Angular again, what we have here is just a base application setup, and it just has this navigation area using Angular material. And within that, there's a routing in here. So our first screen, no matter what, we want to hit to home. So if it's a blank path, it's always going to bring up your home module. So if we dive into that home module, you can see that this home HTML, that is that part that we were looking at the very beginning out here. So that's this room right here. Nothing special really going on at that point. Now, the minute that they actually enter the room here, it's going to jump over to our next route. And if we take a look at our routing again, it's going to be a room with an ID. So it jumps into our captures module. And the routing for this has just a base route that goes to the captures component. So this is kind of where the magic of the app starts to begin. There's a header that's kind of listed out as this card header, and that part is shown once this loads. That's this top part here with the change camera on the media. The next part is this next div, and it has the video portion, and this is kind of a big part. So that's that media query, and it's using the media query to display a video HTML component there. So this kind of video piece right here is what's handling that part. And then the next part is App Firestore. So we'll jump into that right after we kind of cover more of this captures piece. So on the capture screen, there's a lot of code going on here, and I'll try to break them down the best I can. So the different options that are laid out here, the first one that's very important is this view child. That view child is actually grabbing the video HTML component that we just looked at. So if we were to split screen here a second, so that's this video right here. Now, after we have that video component, we can do a lot of different things with it on the view. So we're able to also switch the video input, as you saw I was doing between my laptop that's over here versus my 4K camera, which is up there. So that becomes very important once you're doing mobile, because you can do front facing or rear facing. That will capture that. So a couple of just cleanup items we have here on destroy to stop certain things so you don't have a leaky memory issue going on there. The piece that's important here, if we go to our switch video input, is the initialization of the webcam. So once this occurs, we actually start to use that get user media. And once that media comes in, we actually get a straight stream from that. So the cool part about this, the way that this is laid out, is in our stream, we can start to just feed that directly into our Face API. So you can see here this call out to Face API. If I go back up to the top where that's defined, that is from the Face API.js package. So again, that was coming from Just a Dude Who Hacks, Face API. And again, this whole Face API, it's built on top of TensorFlow. That's why we keep talking about TensorFlow. It's just that it's specific models that are driven. So the models that we want to look at and what it loads is this thing called MobileNet version 1 model, and also the face expression model. So that face expression piece is this part, that happy, disgusted, that's the piece of that. So you can load up as many models as you want. And what we've done here is provided a location for those to be loaded from. So if I take a quick peek in my assets folder over here, you can see here's the different models that it's able to use. Right now, we're just using the face recognition pieces of this and the MobileNet pieces. So at that point, we basically want to start detecting, and right now I have this set at every 1.5 seconds that it kind of rereads to see what the emotion is. I found that's pretty close. I've ramped it all the way down to like 0.2, and Firebase, Firestore especially starts to freak out a little bit. Firestore only handles to a unique document writes up to 1 second of consistency. So you have to be careful, not necessarily on these writes because they're all unique, but once we start into the cloud function side of this, it becomes a lot. So we can talk about that as well. So as you can see here, what's happening is we actually create this detections piece. And when we're in here, we're saying detect all faces and provide a minimum confidence. And we just describe that up here. So like at 70% confidence, if you have that out there, let's go ahead and grab it. And what we do after that is we can start to feed that to a behavior subject right here. So we map those different facial expressions out and we feed that into this behavior subject. And what that allows for is us to kind of dial into different components that are listed on our captures page. So if I jump into the captures page that we have listed, this captures piece, we actually have set up, and the reason we do it this way is we were going to compare Firestore and DataStore. Like I said, you can jump into the repo and turn this on. It's just not perfect yet, but I'll have a tutorial up on CodingCat Dev to walk through this for sure. So these expressions are then inputs to this app Firestore. So this is where the Firestore piece starts to take hold. It's bringing in that input for each of these behavior subjects. So if we take a look here, the first piece on this component is it's checking for Fire Auth, which is Angular's Firebase part of this. So the Firebase side says, hey, do you have a user yet? And if not, why don't we go ahead and create one anonymously? So that's where that anonymous piece comes into. So if I take a look, here's my local host. I'll just move this over for a second. Oops, there it is. So this might get a little hard to read. I'll bump up the font in a minute here. But as you can see, it's created a user, and it will keep this user as long as your local storage isn't cleared out. You don't have to worry about like relogging in and creating multiple users. So the authentication here, which I've tried it several times, as you can tell, if I put this in, here is the current user that I just created and logged in with. So we're going to use that just because of this UID, and every time that we come back to this page, it will reuse that anonymous user. Now, in a lot of different apps for Firebase, what you can do with that is take them through another flow and say, hey, we know you've been trying this product out. Would you like to now log in, and just switch this UID to an actual like provider? So whether it's Facebook or just email, you can switch that out at that point. So now comes the part where we're actually feeding up the data. So let me flip over again. So once we have this, this Firebase authentication, we're going to go through and update the room. So this part of the talk kind of starts to talk specifically about how to write to Firestore and also update the front end. So we have a bunch of different emotion counts in here, and those are all updating this area. So each one of those has a different area that it's updated to. However, the right side of that is saying, okay, take those emotions, and what we're going to do in Firestore is write it per user right here. And so if I jump over into Firestore, if you're not used to Firebase, Firestore has the way it stores its data is between collections and documents. So every document has to have a collection that surrounds it. So in this case, we're a couple down here. So we're in rooms, and then GDG UK I2, and then we actually have the users right here, and here is my current user. So I will actually jump ahead just a smidge because you guys are probably like, I'd like to try this out. So let me go ahead and share the URL with everyone. We'll talk about the hosting at the very end, but we can share this out. Let me shoot that over. There you go, Ricardo, if you can share that out. Okay, so back to this for a minute. We might start to see more users now. So when we're doing this, we're actually taking these emotions in. So you'll see the neutral here. If I start to go like this, it actually picks up the happy or sad. And the reason that it allows for more than one is the fact that, like I said, you can put that group photo up. So if you're trying to do this and there's a large room, so you're doing it remotely from London to Michigan, where I'm at, you can actually start to see the trends that are happening in an entire room. Even though that single user, we basically think of that user as the person with the camera, essentially. So if I jump back to the code here, at that same time, what we're doing with this emotion count is we're actually looking for rooms with users, and then each one of those emotions, we actually have a emotion count for that specific user. So it actually says, hey, if this is neutral or sad or surprised, which that's the emotion that we send in, go ahead and set up an observable to be monitoring that every time it updates. So not only are we writing at the same time, but we're reading this specific document in real time or near real time. Okay, so the next part of this, this is kind of interesting, cool setup. What I've done here is also used Firebase's real-time database. And this is actually from one of their documentation, so you can check it out. I pulled it straight from that. What it allows you to do is to do some cleanup. So if I take this user again, let's say I close this browser. See how that popped away? That is because in the real-time database, we actually have a status for that user. So anytime this user falls offline, you can actually track whether or not they're on or off by doing that. So see how it just went back online? That allows Cloud Firestore to be cleaned up. So that is the very start of where our cloud functions start to come into play. So let me switch over. Okay. So all of the code that we've looked at so far has been just in Angular and on the front end, and that's where TensorFlow.js or the Face API lives. So there's a lot of that process going on. From the back end side of things, and where we start to get the graph. Uh-oh.
I think we lost him.
Yes.
The connection dropped.
We just sent him. Oh, he's back on his mobile.
Hi, Alex.
Laptop died.
Oh, do you hear us?
Yeah, can you guys see me okay?
Oh,
yeah.
Sorry. I'll try to keep going. I think there's too many video inputs for my laptop to handle.
Okay.
Yeah, so just to kind of continue talking, I'll try on my phone while this loads over here. Oh, did I lose you guys again?
No, we're still here, don't we? Oh, okay.
Okay.
So let's just fill in the gap while we wait. And he's back.
Yeah, having struggles. Sorry, guys.
No worries.
My laptop is resetting as we talk, but I'll just try to talk through the pieces, or we could talk about questions that you might have while this is rebooting too.
You can wrap up your presentation in general terms, and then we can move to the questions in a few minutes. What do you think about it?
I'm sorry, I missed what you said, Ricardo.
You can wrap up your presentation, and then we can jump into it.
Yep. So I'd love to show it on the code once this comes back up. I hope. Here we go.
We lost him again.
Yeah. Okay. No worries.
Okay.
I don't know if he'll come back. He's only got a few. Like he said, he was wrapping up anyway. So it's up to you. Do you want to?
Let's wait for a few seconds.
Let's just wait a few more minutes.
Yeah.
Oh, he's
said.
back. It was his laptop, I guess.
Fingers crossed.
You guys see me yet?
It's all yellow.
It's all yellow, but we can.
Super weird.
Hey.
There we go.
Cool.
Sorry about that.
No worries. This is a live.
I don't know what the yellow is. That's really bizarre. So yeah, the last piece, I'm just gonna check in with the guys to make sure I haven't completely lost everyone again.
Yeah, we're here. Don't worry. We'll stay here just in case.
Perfect. So the last piece that we kind of wanted to flow through at this point is the cloud functions. So once we're doing all this updating, there's a lot of things that we need to handle in the back end of this for the Firestore side. So if we jump into these functions over here, let me just shrink that away. I put them all in one. I typically put it in several folders, but just to help simplify. So the last thing that we kind of touched on was that status and how to remove a user in Firestore once that status goes away. So we're actually, again, this has the presence piece right here that it talks about. It's really easy to implement. Just follow the docs. What we're doing here is the real-time database actually recognizes the fact that you closed a browser, that user is gone, and sets that status. And then once that occurs, what we're actually doing is removing that user from our room so you don't get thousands and thousands of leftover users in your Firestore documents. Now, you might say, well, you still have them in your real-time database, but you could set up a cron job there to clean up as well. So that is the first part of that. The second part of that data for our cloud functions, do I have it open? Here we go. So the second part of this is pulling in different statuses or not statuses, I'm sorry, different expressions into your room. So even though we had the users over here, we're now taking those expressions and basically anonymizing them. So if you think of this as kind of dumping out to a data lake or something like that, it's taking and snapshotting throughout that entire course of time the different expressions. And then what we also have from that is an aggregate counting it. And every minute it goes through and checks the different happies and sads and things like that, that will then list out by year, month, date, hour, minute type of thing. And that is what drives our graph. Let's see if I can get this to actually load. Let me jump back out to the real site here. Close that. So you'll see here, as we start to aggregate, these are the different happy, sad, those items. And you can kind of watch and see what we're really looking for is a lot of green. We want happy faces out in our crowd as we're talking about crowd emotion. So that is the goal of this entire thing. So the idea would be you could send this link out and
we don't see your screen. We only see a yellow screen.
1 second. How about now? Should have that shared back. Yep. Okay. Sorry about that. Probably catching up a little bit here. So let me back up just real quickly. So just talking about the different aggregates, we have the expression coming in that we're anonymizing. So it takes the user ID out and puts it on the entire room. There's a cloud function then that picks that up, and every minute it just takes and puts these different emotions back into that minute of time. So as your talk goes on, you can see the graph below here. And this is what we're looking for happiness, basically, or other emotions like surprised. So that goal of this would be to send out a link similar to this data store versus Firestore at the beginning of your talk and send it to everyone. Maybe there's some other voting opportunities and things like Kahoots that you could put up, but you could leave this running just to see the reaction of people as you give your presentation, just like this. So hopefully I can hit a lot of green one of these days. So that pretty much wraps up everything other than hosting. The hosting side of Firebase, because this is an Angular application, it's all on the front end, including the model.js. And when we have those models, they run in the browser. So what you can do is just do a ng build And then because Firebase has hosting included, all you have to do is Firebase deploy hosting, and you end up with this site just like this. And that's all there is to it. It's fairly simple. So I'll throw up the conclusion slide. Web dev's awesome. I love doing this stuff. And come join me at Coding Cat. Any questions?
That was amazing, Alex. Yeah. I have one question. What version of TensorFlow.js are you using?
So let me check. I don't know if I have the TensorFlow version because I believe, yep, 2.0.1.
Cool. So you're using the new one, the latest one. Cool.
And then MobileNet is 2.0.4. And if anyone cares, the Face API is 22.2.
Cool.
Happy to pull up, happy to allow PRs and stuff to this thing. It's a work in progress as we go. So.
Cool. Thank you.
Yes, thanks very much.
Thanks,
Appreciate
Alex.
you having me on.
Cool. Our next speaker is Henry Ruiz. Henry Ruiz is a student, and he, along with other students, published a paper called AI Powered Banana Diseases and Pest Detection. And he's going to talk this is another TensorFlow talk. He's going to talk about end-to-end computer vision projects. Hi.
Hello, guys. Can you hear me?
How are you?
We can hear you.
Perfect. So, I'm gonna turn on my camera for a bit. Let me check if I can't. Okay. Can you see me?
Yes. How are you?
Okay. Nice. How are you? How are you going, guys?
We're good, thanks.
Yes.
Nice.
It's all yours.
Okay. So, anyways, thanks so much, guys, for the invitation. So today, okay, before I want to introduce myself one more time. So I am Google developer expert in machine learning and a PhD student in Texas A&M University. And right now, I am focused developing open source tool for agriculture purposes. So mainly using deep learning and machine learning. And today specifically, I'm going to talk about one of the applications that we have developed to classify banana diseases. And I'm gonna basically explain how was the development process, so you can guys have a better understanding or an idea how develop this kind of application works. So, okay. First, I'm gonna start doing a short introduction about what is artificial intelligence, what is machine learning and deep learning. I'm gonna go to these topics pretty fast since we don't have so much time. But I know that sometimes when you start, if you don't have previous experience working with the AI before, so if you guys doesn't have any experience working with machine learning of this stuff before, this is very overwhelming when you start looking at information in Google about these kind of topics. So I'm gonna make the difference between artificial intelligence, machine learning, and deep learning, because this is one of the main confusion when you start exploring in this world. So artificial intelligence is basically a research area of computer science focused specifically in develop different algorithms and methods focus in try to mimic some natural behaviors in our machines or into our softwares. So just to make an example, so a few years ago, MIT published a paper about how they were using how the ants works, like how they organize the colonies, how they interact between them, how uh, each of them have a specific role in the colony. And they were trying to see if using computational algorithms can try to like gap these kind of behaviors into like how the networks works. So it's basically how we can optimize the way how we send a package to the network. So this is basically artificial intelligence focusing develop this kind of methods, models, and this is a huge area of research when you're gonna find information about topics like generic algorithms, optimization, computer vision, speech recognition, etc. And machine learning is just a subset of this kind of methods. And machine learning in particular is basically try to extract patterns, try to extract like fixtures in our data that we can use to do predictions. So we basically have an historical data, and we use that data to do predictions. And one of the machine learning methods is neural network, and this is what deep learning is about. It's basically the evolution of neural networks. Since like right now we have more computational capabilities. We have right now cloud computing, different this kind of platform to run more complex and more sophisticated models. So that's mean that this is why right now we can have more complex architecture with more layers, with more parameters. So this is why right now it's called deep learning. And these kind of methods are also known and brain inspired, because the way that how these algorithms work is as you have a set of layers stack, and these kind of layers stack different information or different patterns from your data, and I use those patterns to do the predictions. So if we need to do a formal definition of what machine learning is, I'm gonna give you two definitions. One for a general point of view. Is a discipline focus on how to build systems that automatically improve according to their experience. And we talk about experience in the software development. It's just basically the data that we are collecting every day in our transactional software. And if you guys want to like have a more specific research-oriented definition, it's basically we have we basically train a mathematical or a statistical model using historical information to infer or predict the value of a variable. And this is very important because the nature of the variables going to define what kind of problem we are facing. So in this case, if the variable that we want to predict is continuous, we are talking about a regression problem. If the variable that we want to predict is discrete, we are talking about a classification problem. So here, just to make an example. So this is imagine that you guys going to develop a deep learning or machine learning model to predict the stock price based on historical information. So in this case, as you can see that the variable that we are predicting is continuous. So that means that it's a regression problem. But you need to predict, for instance, you have a set of images and you want to say this is a cat, this is a dog. We are talking about a category, we are talking about a label. So in that particular scenario, we are talking about classification problem because it's a discrete output. How these algorithms actually learn? So there are three different ways how these algorithms works. So if you have a set of data and you just want to like see if there are some kind of relationship between the observation that you have in your data set, just think about that you have information about cancer patients and you want to like see if there are some fixture that you can use to identify a structure that allow you to create clusters. So in this case, we are talking about supervised learning. So that means that here we don't have an hypothesis defined. We just have a data set, and we want to like the model try to deduce a structure present in the input data. It is very useful for pattern recognitions. And supervised learning is more like how we actually learn. We learn basically on examples. When we are a child, so you know that our moms were saying that all the time they are saying this is a cat, this is a dog, this is something else, and your brain internally is collecting all of this information from the physical world, and so then later when you are able to identify the objects around you. So that's mean that for supervised learning, you need to provide to the algorithms with examples. So that's mean that if you want to train a model to predict cat and dog, you need to provide images for cats and images to dogs, and the algorithm going to trying to find a functions that do that inference, that do that classification. And reinforcement learning is just basically you have an artificial agent into a world. Just think about in a environment, in an artificial environment, and the agent going to learn by itself, extracting information or interacting with the environment. So this is just basically a general idea about how in this case, so you see that you don't need to provide example. You just need to have the agent, and you define a set of policies in your environment, and the agent going to follow those policies and going to learn based on the interaction with the world. And there are different algorithms according to the problem that you have. If you have a classification problem, so this is some of the most commonly used algorithms. And if you have a regression problem, you have a linear regression, super vector regression, decision trees, etc. And so there are different kind of solution available to start exploring machine learning and apply that in your real work. So in this case, it depends of what you guys want to do. If you guys want to just you are working for a company and you need to do just something in particular, but you know that this kind of stuff is not the core of your company, so you can just basically go ahead and pick one of the web platform, including Google Cloud, and I forgot to put here. And but if you want to go more in the implementation of these algorithms, you want to do research, so you can go like for a solution like TensorFlow, PyTorch, Keras, Fast AI, of this kind of stuff. And if you want to go even more deep into this huge ocean, so you can use a library like OpenCV, SciPy to do the implementation from scratch. So let's talk about application. Today we're gonna just focus in one of the application of deep learning and machine learning, which is the computer vision. What you can see is just one of the different ways that you can use machine learning in your implementation. And computer vision is focusing in also a computer science research area, focusing in implement algorithms and methods to extract information from the images and try to create an understanding from this data. And we have different problems in computer vision. So we have a classification, for instance, when you have an image and the model going to predict this is a cat, this is a dog. Or we have our object detection. We have object detection models when you want to predict what kind of objects are in the images, but additionally, you want to know exactly the location of them. An instance segmentation is a pixel level classification. So that means that you're going to get the location of the objects along the class of the label, but also you can extract exactly the region or the pixel that belong to that particular object in that class. And if we compare human vision with machine vision, so we use our eyes to collect information from our environment, and all of that information going to our brain, and in our brains internally, like we are extracting feature that allow us later to identify those objects. But if we talk about machine vision, just think about a computer vision software or something like that. So for that, our input going to be the cameras, and we're gonna use the cameras to collect information from the physical world. And once we got those cameras, we can use image processing to extract different information from that images. So for instance, you can get information about the color, you can get information about the shape of the object that you're, and this is image processing algorithms. Then you have those features, and you train a machine learning model to do prediction based on that information that you extract using image processing. So in conclusion, machine vision is the combination of image processing and machine learning and some other stuff that that helps to try to mimic the human vision into an artificial into an artificial thing. And today I'm going to explain how we developed to mine it. This is an application that people in Africa and Asia, in Malaysia, they are using to identify banana diseases. So this is the user interface. This is the name, how the application is available in the Play Store. And you can see here some testing that they are doing in India. This is the title of the paper. You guys, if you want to get more information about the implementation, almost everything is here in these publications. You can go ahead and explore what kind of model we trained, what kind of accuracy we got, and everything. So this is the development pipelines. So we first create a data set of images. We're gonna discuss more about the data set in the next slide. So we collect the images. So we have contributors around the world. So they basically go to the field. They take up pictures of the different diseases, and they labeling them. Labeling means since they are experts in the field. So see, this is what they used to do every day. So they just take the images and create the bounding boxes around the location of the diseases. Then we split the data set in 3 subsets: validation, training, and test. And we train the different architecture, different object detection models, and for doing the detection. So these tools that I put here, CVS Studio and Falcon CV, these two, there are like two open source solutions that I developed for this implementation. So I'm gonna give you guys the link after the presentation finish, and you can go in and use it. CVS Studio is a tool to do the tagging of the images for any computer vision problem. So you can import the images in CVS Studio and tag the models for do detection and segmentation. And Falcon is a Python library that facilitates the training of different object detection architectures. Just some information, we collected around 30,000 images in India, Africa, Malaysia, Colombia, and Asia. And this process took about 4 months. We focus mainly in 6 diseases. We collect 12 raw images. We got 30,000 annotations. We train 6 models, 1 model for each part of the plant. I'm gonna show you that soon. And we have 8 classes in total. So you here can see the distribution of the classes. We have a healthy plant, we have a drive plant, and we have the different diseases: core wilt, fusarium, yellow cigatoka, black cigatoka. And this is the number of annotation that we did for each part of the plant for each, we have the leaf, we have the substem. You can see here in the images for the entire plant. This is for the leaf. This is the substem. This is the bunch, fruit bunch. And this is the fruit. And you can see that here there are some blank space. And this is mainly because there are some diseases that only apply or only got for a specific part of the plant. So you can see here some examples of the predictions of the models. So this is the substem, leaf. We're gonna go fast because we don't have so much time. And you can see this. We basically train a multi-class detection model that is able to recognize in an image the part of the plant that are affected. This is the architecture that we use. We use a Tesla M60 for train the models. Each model was trained for around 15,000 epochs. Okay, we have time. Okay, so we train a model for we train each model for around 50,000 epochs. So you can see here the architectures. So we have the faster RCNN Inception version 2, and we use that architecture for all the models. Remember that we have a model to predict diseases in the entire plant, leaves, pseudostem, fruit bunch. This is actually one of the problems that we face. Initially, we tried to create one model to predict, to detect the specific diseases in all the plants. So you know that we basically try first creating only one model, but we didn't get good results. So this is why we decided to separate this in different models. So this gave us a better results. And we tried with 3 different architecture, or application works in offline and online modes. That means that this is why we try also with MobileNet, because it's a single shot detection MobileNet, because it's the kind of architecture that are able to run in the mobile devices. And this is how it works. So you just pick here the part of the plant, you take the picture, or you can take from the gallery if you took the images, you took the picture previously. This the application going to give you the prediction, and then going to give you the description of the disease, symptoms, and how to control it. This application is in like 5 different languages: India, Swahili from Africa, and 3 more that I don't really remember. And this is some of the constraints that we face. So something that we got is like there are some symptoms that the symptoms basically change depending on the state of the disease. So that means that we consider that when we were creating the data set. We collect information in different stage of the disease, because this is going to give us more accuracy in the predictions. And sometimes we get misclassification, specific, even more when like the application is working in offline mode. So this is why actually we use the location, so in this case the GPS information, to, for instance, this kind of disease, yellow sigatoka, this disease only happens in Africa, but there is another disease in Asia that is very similar. So that means that what we did is use the GPS information to tune off some diseases according to the this is not the final solution, but we keep working and try to improve the models. This is how we do the deploy of the application. What I'm saying, the application works in the 2 modes. Obviously, the online mode going to give us more accuracy in the prediction, and the reason is because the models are running in the backend in a AWS server. So that means that we are able to work with more sophisticated architectures. while the offline application we use mobile net. So that's mean this kind of model sometimes doesn't have good accuracy. So that's mean that you need to balance somehow how you can coordinate that. So we use flags. We create an API for the online version. Basically, the API receives an image and do the prediction, get the prediction back to the mobile, and display the results. If the mobile device doesn't have internet, so the application going to pick the offline models. And we for the online version we put everything in a Docker container and we host in AWS. Right now we are migrating to Google Cloud. Seems like the Google Cloud give us more flexibility in terms of the deployment. So just to finish, this is basically the general pipeline of any computer vision solution. We develop and train our model. We can use different use different tools like TensorFlow, PyTorch, MXNet. This is a deep learning framework from Amazon. So once we train the model, we package the model in a Docker container, for instance. So then we validate how that model works in the different hardware, and then we also do the validation of the model itself, if the model is working well or is doing good prediction, everything, and we deploy the model in the device target where we're gonna put. So this is all. So we right now are trying to do the same for satellite images, and this is one paper that we just released in November. It's basically the same that we did for banana in the phone in the device, but we are using satellite images. So you can go ahead and find this paper. So you can find information about how we can use almost the same pipeline for doing the same with satellite images. Okay, I'm gonna share some stuff about the implementation. I hope that I have at least 5 minutes to show that. So this is the application working. So this is the home of the application. There's a short description about the application itself. You go here, you pick the part of the plan. This is Ubuntu, and here you can just pick the part if it's the entity plan. See the stem. So I'm just gonna go, for instance, here. I go to my images, pick the image that I want to use. I do the predictions. I got the prediction box, recommendations. This is gonna show me that this image we got Santomonas. So I just click, and I'm gonna get the description here. Some images about the disease, symptoms, and how to control it. And this is how the application works. We developed the application in Java. So we are working right now to try to see if we can migrate the application to Kotlin, and we can just see that in the way how we import the models is in the assets folder. We have a model folder here, and we have the TF Lite models here along the label maps. The label maps is the classes. So what else? I can just show some stuff about the implementation. So there are two classes here that do all the job, but so you just use the TF Lite interpreter to load the model. You specify if the model is quantized or not. So then you get the image data, you do the prediction, you get the outputs, and you return the outputs like a list of objects. So I'm gonna show you how we do the tagging. Let me show you guys. This is So this is CVS Studio. This is the application that I developed to do the tagging. It's open source and you can use it free. So here you just create a new data set, for instance, fruits, and you go into the data set, import the images. So I have some data set already loaded here, like cats and dogs. And there are different kind of annotations. You can open the image and you can go here and make a rectangle. You can create here labels. So you're gonna say, I wanna create a dog class. I specify the color. So then later I can say this is a dog, and you can see that the color is changed. And we also have the option to do other kind of annotation like circles. You can do polygons. Like if you want to go and train a segmentation model, you can go ahead and use CVS Studio for that. Or even if you have a train model, you can go here and import the model from GitHub, and you can right click in the model already trained, and you can do auto labeled. And using a trained model, it's going to try to do the annotations automatically. And another stuff that you can do here is there is another pre-trained model that I use, which do the prediction of the max based on string points. So you can just click 1, 2, 3, and 4. We have 4 points here. And you do a space, and just with these 4 points, the model is going to try to create the mask. So you can see here. So this is one of the tools that have, when you do the annotation, you can export the data set in different formats. And this is how CVS Studio works. And just for finish the presentation, I'm gonna show you my GitHub repository. So this is CVS Studio. It's open. It's completely open source. You can go ahead and install from pip. But this version is working with the PyTorch. But you can. I am currently working in the version 2 to support TensorFlow Hub, pre-trained model from TensorFlow Hub. So you guys are welcome to contribute. If you want to contact me, and if you feel like this project is interested and you guys want to work with that, you can contact me in LinkedIn or Facebook, whatever. And this is Falcon. Falcon is pretty cool because if you guys have previous experience working with the TensorFlow Object Detection API, you're gonna notice that sometimes it's really, really confusing, all the kind of command line commands that you need to do for convert the images into TF records, do the training, and all of this stuff. This is very confusing. So basically, I create a high-level API, and this high-level API it's just basically a high-level API in the top of the TensorFlow Detection API and in Detectron for PyTorch. So we want to support multi-backend. And what you use, these have different tools. One of the tools is if you don't have images and you want to start exploring this architecture, how this model works and everything, there are some data sets. So you can use the data set module, and you can say, I want to download images of cat and dog. I want to download for each class 4 images, and I want to load in memory batches of 2 because I don't want to saturate my CPU. And this data set is a very known data set in computer vision. It's opened images. Is this one. So this is a data set with so funny. This is a data set with the annotations already. So you just specify the name of the class, and Falcon going to download the images for you. I'm going to create a folder structure that you need to do, that you need to have to train the models. And for the tensor to train the model, is just you create a dictionary. You specify the name of the model. You got the name of the model from the zoo. There is also a function in the API of Falcon that allow you to list the models available for detection problems and segmentation problems. You specify where your image are with the annotations and where is the output when you want to put the train model. And you just using a context function here, you say I want to build the model using this configuration, and I want to train my model by 2000 epochs. Please take the 30% of the data set for the validation. And then after the model is trained, there are some examples when you can go here. And in this case, Falcon also have a function to convert to TF-Lite. So you say model to TF-Lite. And with this line of code, you convert your model into the format that you want to, that you just use into the mobile applications. So this is the trained model functions. You can see just model, images, etc. That's it. Okay, so I think that this is all that I guys want to show you. Feel free if you have more questions. And yeah, so this is my information.
Thank you, Henry. That was very insightful.
Thanks, Henry.
Thank you, guys. Do you have any questions?
No, we
don't
have. There are some comments, but I will pass you offline those comments, YouTube's comments. So thank you for your talk. That was super insightful about all the analyses and all this stuff. We are going to share the links of your papers and offline in the YouTube chat.
Okay, thank you guys so much.
Social media. Yes, thank you.
Okay, thank you guys. Bye.
Thanks. Bye.
So just like Henry, you can have your JetBrains licenses. You just only need to tweet about the event and use the hashtag. It's DevFest and DevFest UKI. In the meantime, we are going to have a coffee break, and we are going to be back in more like 30 minutes. So we are going to be back in 4:45. And just to wrap up for our final block, and please don't go, because we still have some interesting talks ahead. So thank you and stay.
Thanks.
See you in 4:45. Hey, we are back for our final block. And in this occasion, Karan Balkar will be talking about integrating Google Assistant for continuous integration, followed by Tim Ruffles, which is going to talk about Go interfaces, the tricky parts, and then finally closing the afternoon, Daniela Petruzalek with Apache Spark 101. We are going to have a after party, so please don't miss it. Now, for our next speaker, David and Jana are going to introduce him.
Hi guys. Hey Yana. How are
Hello.
you?
Good.
Great to see you again.
You
The
too.
last block of the day. I'm quite looking forward to this. I'll just bring in Karan. Karan, how are you?
Hey, David and Jana, I'm fine. How are you?
Doing really well. I gotta say, when I saw your application coming through, I was like, "Ooh, how does he do that?" Being able to get the Google Assistant working with Jenkins. I know a lot of people when they hear Jenkins, they go, "Oh no!" But I want to see this. This looks awesome. Before you get started, though, I've just a few questions for you. I know you're a published author in poetry. Is that right?
Yes, that's right, David.
Have you sold many copies? Go on, tell us. How popular is your poetry books? Are they love
Well,
poems or technical
okay.
poems?
Okay, so yeah, it's a combination of, I think, technical poems as well as something related to my personal life as well. Roughly, it has gone like I've sold around like 150 plus copies, which is around the globe.
That's awesome.
Includes countries like UK, US, and India as well.
That's fantastic. I'm delighted for you, sir. It's a great achievement. It's not something that's easy to do. My hat is off to you. Also, you did a talk on India's first skywalk in Sikkim. Is that how you pronounce it? Sikkim?
Yes, it's one of the states here in India. So yes, that's true, and it was really an interesting one as well because it was at a really high, like a nice altitude where you can, feel the atmosphere was so good. So it was a perfect place, I think, for a talk.
So was it like on the skywalk or in a building adjacent?
Yes. Yeah, it's like a proper skywalk. It's not the ones we see in buildings, but a proper skywalk where you can actually feel surrounded by nature and a wonderful atmosphere there.
I've seen pictures. It's beautiful. Yeah, that's all.
That's absolutely amazing. We've had some very interesting talks done in strange and wonderful places. Like one of our speakers earlier on today, David McKay, did a talk in a warehouse in Amsterdam and in a nightclub in Berlin. I mean, those just sound awesome. What we're really letting the side down, I feel a little bit. We're just online, whereas these guys are doing talks on a skywalk, in a nightclub, and that's cool. Anyway, yeah, that's they're brilliant stories. So we don't want to take much of your time, Karan. We know you've got a very interesting talk. When I'm excited to see myself. So we'll just step backstage and let you get on what we'll be watching from back there.
Okay, thank you, David and Jana. Okay, so before I begin, let me thank the team of GDG UK and Ireland for putting this together and giving me this opportunity to spread or talk about this topic. So thank you so much. Okay, so today's topic is, as the title suggests, integrating Google Assistant for continuous integration. So before I come to the main topic, let me quote Albert Einstein, and he said, "So in the middle of every difficulty, there lies opportunity." And this is particularly evident today. So this is what the world is today. So we are all, or most of us are all working from home. So we have our daily virtual meetings, as we call it now. Social distancing has been the buzzword nowadays, so everyone is aware of this thing. And workspaces are slowly evolving. And all of us, we are getting used to the term that is now becoming popular called the new normal. So this is how the world exists today. Okay, so let me take you a little back in time. So as a software developer or as a software professional, I'm sure like many of you might have come across certain concepts or certain terms in your day-to-day life. One of these terms is called agile. So agile, as you might heard of a lot many times, is basically helps you. It's one of the software development models which helps you to develop projects more efficiently and with better quality. The fact about agile is that it's more result oriented. So as opposed to a traditional waterfall model where you'll actually have to wait till the frag end to view the product, agile is something that you can actually view very like phase. You actually can get an idea of how the product would eventually appear or look like in various phases, which we term as sprints. The second term, or the second most common concept, I think most of you might have heard, is about continuous integration. So continuous integration, again, as the name suggests, is basically bringing everything together in a one kind of in a centralized environment where you do testing, deployment, and building of your code or any kind of assets, and you do it often. So that's why the term continuous. So this is the two concepts that most of you, I think, might have heard. But the one that excites me right now is voice first. So that is the third concept or the third term that I would like to share with you. Now, voice first has been there for a long time as well, but the thing that the voice first technologies are going to be the next big thing is something that excites me personally. So why voice first is going to be the next big thing? Because voice first helps makes a conversation more natural. So they say that a conversation is the best way to solve a problem, and voice first is just doing that. Also, it has improved accessibility to a great extent. Okay, so moving on. So we all love data, right? So we all love to know about what different organizations or different research firms have been predicting. So for example, here is a quick fact that Gartner is one of the world's famous research agencies. And here is what Gartner predicts. So Gartner predicts that 25% of digital workers will use virtual employee assistants daily by 2021. So this is something that is really it is really going to affect all our lives going forward in the near future. Okay, so now coming to the problem that we all face as developers. So there are certain problems that I think most of us would face nowadays, and I'm sure most of you would agree to it, is that our projects are no longer simple. So we are dealing with complex stuff. We are dealing with projects which are integrating with multiple systems, whether it's SAP or Oracle or any other ERP. We are also dealing with multiple technologies, be it cross-platform, be it native. So projects are no longer those simple kind of projects. It is day by day they are becoming more complex. The second problem that normally we face is about a team size. So no longer do we work independently, right? So we are all situated at different geographical locations in different time zones, and we all work in teams, right? And then our team just continues to grow. So the large team size is also, I would say, a problem. And there is always a high learning curve. So what I mean by high learning curve is that usually in a project you never stick to a particular technology. You always have to be evolving. You always have to come up with something new, and there's always a learning curve that is involved in your project, and you have to do all this against time. So that is where the fourth and the major problem lies, is that you always complain about time, and time waits for no one. So this is again some of the problems that we as developers or we as software professionals face on a day-to-day basis. Okay, so I talked about data. So data basically is a collection of facts, but what we need is not data. We need something called as information. And information is basically how we understand those facts. So today, what we need is information access from anywhere and everywhere. So basically what I mean by information on the go is that as developers or as maybe DevOps or working in a DevOps environment, we would normally would like to know what was the certain informations about our project. So when was the last build delivered, or how many test cases actually failed or passed, or what actually caused a broke, caused a broke in the last commit. So these are some informations that we all need, we all need to know about, and this is something that we as developers are quite often asked about as well. So what are some of the challenges that we come across nowadays? So the first and the foremost challenge that we come across is about dependency and communication. So this is particularly evident in cross-functional teams. So when I say cross-functional teams, it basically comprises of different functional areas like product, like marketing team, a product team, or a sales team. And typically in a technical team where you have like multiple roles, whether like it's a UX designer or a developer or a tester. So there's always a kind of dependency that exists between each one of them. For example, like it will be difficult for you to start implementing unless you receive a visual design which is approved by the UX designer, and the tester would not start testing as long as you have implemented a particular module. So there is always some sort of dependency that exists. Communication again plays a very important role in terms of whether when it's a larger team size and if you're actually distributed across multiple areas or geographies where even the slightest of miscommunications can actually end up building a wrong product. So that is how crucial or how critical communication is, and it is certainly one of the challenges that people face right now. The second challenge is about time and cost matrix. So the effort that we spend in building, especially enterprise-based portals, it is something that we invest a lot of time in and we invest a lot of effort in, but at the end of the day, we do not actually go back to maintain it. So they are always like lying there. So it's like those kind of portals which are there, but we do not actually try to revamp them or upgrade them. So these are like the old enterprise portals that we use typically, and we spend a lot of effort in developing them. The third point is about zero manual intervention. So this is basically again one of the challenges, because right now in the age of automation, all of us would need access to information in a more automatic manner where we do not actually have to physically access a machine. So this is something that we need as of now, but it is one of the challenges that I see as well. And the last and the most important challenge I feel is about organizational culture and methodology changes. So this is basically when you, in organizations which have transitioned. So let's say you transition from a waterfall to an agile model. So there's always some challenges, and this transition cannot happen overnight. So there is a lot of background work that has to go in, user training, knowledge transfer. This is all sort of processes that are defined in whenever an organizational culture changes. So at this point of time, it becomes very difficult for any organization to actually manage that, and it's something that is also a challenge as well. So these are some of the challenges that I have come across till date. So this is what I propose. So right now I'm going to talk about what my proposed solution is. So a proposed solution is basically creating a voice-based interface, a communication interface that uses simple human language or natural human language. And this particular system or this particular interface would leverage a particular CI framework. So like for this, in case of this example, I have used Jenkins, but it can be extended to any other frameworks like be it Travis or Travis CI or Circle CI. And this can be used to monitor your builds or your jobs and a lot many things that you could normally do using portals or some other mechanisms. So this kind of a solution is basically going to do it help you monitor your jobs or your status remotely. And again, it will leverage latest AI technology. So this is basically talking about dialog flow, where dialog flow is something that I have proposed to use as well. And dialog flow will actually help you to create this kind of conversational interface by using AI and different other technologies as well. And again, this all this would result in providing instant feedback to the users or to the end user without the need of a centralized web portal. So that is the advantage of one of the key features of this kind of a solution. So yes, so this is, I think this is basically the architecture. So this is where I'm going to highlight more on the technical aspects. So as you can see, the overall architecture basically it involves an end user. So the end user can be an agent or a bot, typically as we call it. And the end user basically it sends a request which would be basically a user expression. And the dialog flow system basically will help you to process that request. So that is something called as intent matching. So an intent is basically like an intention. So basically, in simple terms, an intent is like an intention of a user's conversation or something like that. And intent matching is basically matching a particular intent. So let's take an example. So let's say I want to know the status of a particular build. So the build status basically is the intent that I would define in Dialogflow. And when the user basically says a particular expression like "tell me the build status" or something like that, the Dialogflow would actually do the intent matching based on that. So the build status the intent would be then matched, and a particular action would be invoked. So an intent basically comprises of training phrases, parameters, actions, and responses. So basically, the training phrases are something that you define for the particular intent, and the responses is something that also you can provide, and actions is basically the actions that you need to take for that particular intent. So this is basically talking about how the integration or the integration module will work. And but there is something that it says what happens after you match an intent. So after you match an intent, there is something called as webhooks. So webhooks, in a very simple term, it is basically like an endpoint. So it's going to be a service endpoint that would help you to connect to any service. So in this case, I would be using Heroku. So Heroku is a platform as a service where I would deploy my services, and these would be basically communicating with the end system. So in this case, it will be a CI framework like Jenkins. So what this would do is that the webhook basically would be talking to the Jenkins via RESTful APIs. So again, these endpoints would be typically HTTPS, as HTTP is not supported, and these endpoints would actually communicate through the CI framework, get the response from the framework, and send it back to the to the end user or the agent. So this is how the overall architecture will look. The second part is basically termed as fulfillment. So when we say fulfillment, basically it means you fulfill the particular request, and that is nothing but the webhook request that is passed from the integration module to the fulfillment module. So this is how the overall architecture of the system looks like. So it's a combination of both like intent matching and webhook integration. So just a quick also a quick note again is the kind of algorithms that Dialogflow uses. So Dialogflow currently uses rule-based grammar and certain ML algorithms. And what it does is that it simultaneously uses that to actually give you a better result. So that is the way it works in terms of giving you the right response based on your user expression. So that is how Dialogflow works. Moving on to the next slide. So what are the benefits of this kind of a solution? Okay, so one of the key benefits, as I mentioned before, is that it can be extended to other CI frameworks. So it is not something which is tightly coupled to Jenkins. It is not that way. You can actually extend it to other CI frameworks as well. And and this can be done simply by modifying your webhooks. So your webhooks can actually be a generic kind of a service which can connect to any CI framework that comes up in the future as well. And the second benefit is again it's voice first. So you not actually worry about training a particular person on any particular tool or anything. He can just use his natural language to communicate with this agent, and can do stuff easily and more importantly remotely without actually needing any access to a particular portal or anything like that. So that is one of the benefits or one of the things that about this particular solution. So moving to the next slide. So yes, so this is basically this is what I was trying to explain through this presentation. Now, many of you might be asking like, what is the future of voice-based interfaces? So I think voice-based interfaces are here to stay, and going forward, I think there are a lot of more work being done in terms of how better can these interfaces be developed. Again, I foresee that there will be support coming in for wearable devices as well. I think mobiles and smartphones are already personalized in a way, but wearable devices or like maybe Apple watches or smart watches are getting also personalized as we speak. And I think security and user verification are again some of the areas which have been worked upon. So this is again very an area which I think will gain some kind of traction in the coming future. And yes, so the whole idea is to make conversations meaningful, and then that is what is I think the objective of of this kind of a solution as well. So this is basically about my presentation. So thank you so much. And if you have any questions, you can always write to me at my email address. So this is my email. So now we will quickly jump into a video which will actually show you a demonstration of how the system is working. Okay, so this is basically the test console or the actions console of my agent. So this is basically talking about how I communicate. So basically the first thing I would ask the agent is how many jobs are running currently. So the agent would reply saying that, okay, you have a total of 1 jobs. So basically whether I want to start or stop a build. So I would say I want to start a job or a build. Okay, so as I mentioned, as I just mentioned, start a job. It'll also ask me to specify the job name. So this is basically again how the intent is working for this particular user expression. So I specified the job name as Hello World. So this is an example project. So right now it has started the build. So this is the Jenkins console. So as you can see, the build, there's already a build in the queue, and this basically build is happening right now. So yeah, so this is about how remotely I could do it using Google Assistant or and Dialogflow. So let's wait for the build to complete. So I'll just pause. I'll just move ahead a little. So once the build is complete, you would get a message. So again, you could ask the agent what is the status of the build. So again, you could type in user expression like tell me the job status. Okay, so now it's saying that the job one, the Hello World job has been successful. So then you can actually go ahead and do a lot of things. So let's say I want to send an email report of this. So it could actually send an email report with the details of the job. So right now I've done that, and it could actually do. This is just maybe a sample, but you can actually go ahead and integrate it with any other system as well. So it's just an example to show that how it's working. So yes, so that's about it from my side. So if anyone has any questions, I think I can take it right now.
That was fantastic. Thank you so much, Karan. That was brilliant. I was looking forward to that demo right at the end there to see how it would all come together. It was very interesting. What gave you the inspiration to try and hook it up to Jenkins of all things?
Okay, so Jenkins is something that I have been using personally, but as I mentioned, that it's not like Jenkins is the only way to do it. I would encourage people to actually come up with something which is more generic, which can be extendable to any other framework as well. So this is something I've also been working on. So this project basically is something that I would be eventually putting out in the community so that other developers can also extend it, can leverage this and maybe come up with certain better ways of connecting to other CI frameworks as well.
Do you have a link there, Karan, handy?
Okay, so right now it's not on any not on GitHub or Bitbucket, but I would soon be doing that. So maybe in a couple of days' time, I would be putting across a link as well. So maybe I can share that with you soon. No problem.
Absolutely. You have the Twitter handle. We're on DevFest UKI. So you can post it up there, and I'm sure it'll be picked up and amplified by the rest of the team. So, well, thank you very much for being a part of DevFest.
Thank you so much. Yeah, and if I think we have 5 minutes, right?
Yeah, sure.
Okay, so I think for the audience or for many of you, I have also composed a short poem. So if you allow me,
of course,
I
sir.
would write. I would. Okay, so here goes. Okay, so hope you like it and hope all the participants like it. Okay, so finally it's time for the most awaited fest, where our knowledge and skills are put to the test, where speakers come together from many different places to discuss problems that a common developer faces. They talk about Google technologies that have made an impact, be it Angular or Dart, or even apps that use Jetpack. Life isn't always about being a full stack, it's about how quickly you can come out from a major setback. As sessions go on hour after hour, one realizes that perhaps this is going too far. As time passes by, everything seems tougher, and that's when they start talking about Flutter. As AI and ML enter through the door, they talk about numerical computations using TensorFlow. But for a guy like me who just works at a store, who plans to quit and can't take it anymore, they say that there's something that I can still explore. No, it isn't cloud or mobile, it's what they call AR core. So, all said and done, when it's finally time to commit, let's think about the future and pledge at this summit. We have to start right now and lay those building blocks. We have to stand together and say, GDG DevFest rocks. So, this is the poem I have composed.
I have a feeling that might get a few shares, Karan. Thank you so much, sir.
That was beautiful.
That was amazing.
Okay, thank you so much, and nice talking to you. And
It
Jana.
was fantastic. It was an honor, sir. Thank you very much.
Thank you.
Thank you. Bye.
Okay, so next up we have Tim talking to us about Go interfaces, what you didn't realize you needed to know. Tim is speaking to us from London, and he's an engineer that has written code for various companies such as Plaid currently, GitHub, and Cloudflare. There's a number of questions have come up in relation to your piano skills. You play piano. You've informed.
Deeply limited.
One question is, how does it relate to your coding skills? And this, like, which came first? And does the speed of one affect the other, or are they related?
Yeah, all good questions. I think recently the speed of one affecting the other one has only been negatively correlated. Being at home so much during COVID, doing two things that both involve like typing at a keyboard or pressing a keyboard, definitely gave me a bit of a bout of RSI. I've been playing music for about as long as I've been coding, but I started out playing clarinet, not piano. Piano is a much more recent thing. But yeah, skills is really overstating it. Like I just mess around on piano and have a good time.
Very good. So there's a determination there anyways.
Oh yeah, definitely. No, I mean, it's so much fun. It's definitely a good thing that doesn't involve a screen. So yeah,
that's true. That's very good. And you also said that you did a talk in Bletchley Park, which is where the Enigma code was cracked. That's very interesting. How did that come about?
So there was a conference run for years and years called Over the Air, which was, I think, a kind of mobile telephony conference at the beginning, when I suppose it was still a kind of emerging, well, yeah, I don't know, maybe. Anyway, it's not running anymore. And they had the most amazing location, which is Bletchley Park, which is out near Milton Keynes, I think, in the UK. It's got the National Museum of Computing there, and it still has this wonderful manor house where they held this conference and hackathon. So yeah, went along, did the talk, which was really fun, saw some amazing talks, which were all sorts of stuff I have no idea about, like how 3G, 4G and stuff works for real, with actual things going, radio engineers, all this kind of amazing stuff. And yeah, did an overnight hackathon.
Too, right?
Sorry,
the mind control at the 4G, 5G.
Oh yeah, exactly. Yeah, we learned all the secrets of the mind control. Yeah, and then we were sworn to secrecy. I'm probably going to end up being like whisked off by some men in black in a second. But yeah, it was great. I wish it still happened. It was an amazing conference and in a very inspiring location.
That's great. Hopefully this will come. Well, hopefully this will come a little bit close to it, being a modern experience of speaking online. Would you like to proceed with your talk?
Yeah, that'll be great.
Perfect. Looking forward to it.
Fantastic. Yeah, hey, as said, I'm Tim Ruffles. I'm currently working at a company called Plaid. We are a fintech API company that powers applications you might have used like TransferWise and Venmo in the US. So my story with Go started when I joined GitHub back in 2018. I was working on the GitHub Actions product, and like many of the people on the team, it was my first professional experience with Go. And many of the people on the team and myself had the experience that it was a lovely language to start using from scratch. And very quickly, you got up to speed because of the way the language is designed. You know, it is designed to reuse so many familiar concepts from other languages. Its entire design is around simplicity, you know, conciseness, the compiler doing stuff for you. So even though we were all complete newbies with Go, very quickly we started to feel like we could ship features, and we were happily shipping features. And you know, it was good. So I was feeling good about Go. And that's when I had an experience that really confronted me with that I didn't know Go properly. You know, I could ship stuff, I could work quite well in an existing code base, but the actual underlying logic of the language was actually not known to me. Like, I didn't really know much about it. And the bit of the language that tripped me up probably would have been a surprise to me had I been asked kind of ahead of time, like what would have been that bit that would have just completely bamboozled me, because it was interfaces. And interfaces in Go didn't seem too tricky when I started out. They look pretty similar to other languages. You know, they work very similarly, they look similarly, the syntax is the same, etc. But I wanted to share this story and talk about Go interfaces because this was the thing that taught me Go properly, like forced me to confront that I can't just kind of happily hand wave and use Go without really understanding it in depth. And the second thing is this journey really took me into the heart of Go, into some of the most interesting and powerful parts of the language's implementation and logic. And also it helped me unlock two of the really difficult to understand, at least at the beginning, parts of Go, which are very powerful, reflection and how you might write like a custom marshaller or unmarshaller in depth. And interfaces, once you've cracked those, these things that can otherwise be incredibly hard to understand become a lot more comprehensible. Okay, so back to the story. There I was, happily shipping features with only the most kind of surface level of understanding of Go, and then something about interfaces really tripped me up. So the example I'm going to use is this very simple interface here. You see it's named, it's called named interface, and it has a single method, a very simple method, this name method that returns a string. So let's implement that method on a implementing type. Here we have a user. You can see it implements the name method. So far, so good. Let's use it a couple of times and see if we can get this thing to compile. Okay, cool. So you can see we are allocating, we're assigning a user struct to a named value, and we're doing the same thing, but taking one of those user values out of a slice. Take a moment to think about if there's anything here that's going to be a problem, or is this going to compile just fine? Well, in this case, it's going to compile for just fine. We know we've implemented all the methods, everything's all good. Fantastic. We know for sure then that user implements named. Let's just try and pass this thing around wherever a function might need a named. So over here, you can see we have this getNamed function, and we're going to pass in a user from two different places. First off, just a user that's been kind of assigned to a variable, and then one on a slice or from a slice. Again, what do you think is going to happen here? Is there any problem, or is this thing going to work? Again, it works. Okay, cool. So, you know, what's the problem? Over here, we're going to do another one, this time just taking a slice of user. We're going to, again, create ourselves a nice slice of users, and we're going to pass it in over here. And this time, the function is accepting a slice of named. So far, so good. Are we going to, what's happened here? And this is the point I got a little confused. Now, I was also running TypeScript in parallel with Go at the time, and this certainly would have worked in TypeScript. So over here, if we go to a TypeScript example, we're going to just, you know, creating an array, a collection of user. We know that we have this user type, which implements all of this named method, and it quite happily passes that through to a function that accepts a collection of named. So here you have a collection of user. We know a user is a named. We can pass one user to a function. Now we're passing it. Works fine. Works in TypeScript. Works in Java too. Same thing. We've got a user implements named, passing collection. So what's going on? A user is a named. Why can we suddenly not use a user as a named in this particular instance, you know, when we're dealing with a collection? Well, at this point, you know, you might think, hey, I'm not paid to dig into language implementation details. I'm paid to ship code. So we might just kind of reach for a bit of a kludge. We might go, let's just slap an interface on it. Let's do a slice of interface and see what happens. Isn't that just like any in TypeScript or a collection of any? Well, let's see if this works. So let's see if it's something to do with the named and user types specifically that's the problem. So we're going to change this getNamed now to accept an interface type. No dice. Still not working. So something was fundamentally wrong with my mental model of interfaces and how they related to collections in Go. Why weren't they working like these other languages that felt so familiar to Go in so many other ways? What was going on here? And at this point, I recognized a feeling. I call this feeling thrashing. So thrashing is when you subconsciously know you don't understand something, but rather than really confronting that problem head on, you thrash around looking for a kludge that lets you keep making forward progress, but doesn't involve you sitting and kind of consciously going, hey, I don't understand what's going on. I'm going to have to sit down and learn this. It's like your subconscious doesn't want you to admit to yourself that you weren't such, a Go expert. You felt you're happily, shipping features, etc., but actually you didn't know what's going on. And again, it's that kind of unconscious thing. We often, use these kind of kludges, not consciously, not being like, hey, I'm going to do this instead of actually doing the hard work. It's just a subconscious way that we quickly kind of can dodge that pain of having to be like, oh, don't understand this properly. This is the way we can keep making forward progress. And it's not, a Go specific thing, of course. I think it's kludges and thrashing around for kludges happens in every field of endeavor. So you might have seen some of these before. If you see a colleague getting confused with a Git branch, someone might say, oh, just check it out and, start again with a fresh copy of that branch. Don't dig into the ref log and understanding Git in any depth. Or in JavaScript, the classic one would be a set timeout. Rather than getting asynchronousy and the event loop into your head properly, just kludge it with a set timeout. And in Go, interface is going to be one of those ones we'll try and kludge with early on in our understanding of the language without doing that hard work of learning. And it's really, it's always this path ahead of us. There's two paths. We can either admit to ourselves consciously that we weren't such the expert that we thought we were, do the hard work, or we can kind of grasp this kludge. But the thing is that kludges often work, but I still think they're a defeat. They don't feel good because we're not growing. They've stopped us growing. We can kind of keep going, keep making forward progress. But every time we do that, we've kind of lost an opportunity to learn, to be curious. And that's luckily what I did this time. Now I want to take you on the journey of where this curiosity took me. I wanted to know what it was about interfaces in Go that stopped collections of interfaces working like collections of interface values in every other language I'd used. So just to check, we know for sure that it wasn't a problem with the user and named type relationship. We know that user implemented named fine. We know for sure that we could use it functionally where we needed a named often. So we could pass a user into a function needing a named. That worked fine. So specifically what's going on here? Well, what I did first off is just to go read, some of the language specification and the blog posts around the language and the type system. And some of you might have been already like screaming at the screen, the spec lawyer answer, which is that a slice of named and a slice of user are distinct concrete types. And that is completely true. That is a perfectly great answer to that question. The fact that a slice of named is a slice of interface types does not make a slice of named an interface type. It is still a distinct concrete type. And we can see that the spec tells us exactly what's happening here. We know it is not an interface type. A slice of named is not an interface type, two distinct concrete types. Of course, a function accepting a slice of named can't be satisfied with a slice of user, right? And another way of looking at this is we know that slices of a distinct type are a distinct concrete type because we can implement methods on them, which we couldn't do if they were an interface type. We can't actually have a concrete implementation of a method for an interface. We have to implement it on concrete types. And of course, a great example of this is every time we want to write a sort, we have to do it for that specific type of slice. As in a specific type in a slice, we have to write a sort method for it. That's the rule. But why can't it be like that? That's a more interesting question to me. Because Go is all about being expressive and clean and doing things for you. The other languages might make you kind of pedantically type out something that's just obvious from the types and the syntax involved. And if Go can figure out how to magically, from one point of view, make a user being passed into a function accepting a named work, why can't it do the same for a slice, a collection type of user named? And that's where the kind of knowing the rules on a type level, knowing the spec at that level can't really help you. Like, why can't it be like that? That's interesting. So I went back and started digging more into what interface values really were. And here is some really interesting hints at what's going on in the spec. Again, the spec isn't going to tell you exactly why, because it's a bit more abstract than any one implementation. But what it's saying here about interface values is not something I'd say about interface values in any other language. So we can see they have a distinct dynamic type, a distinct dynamic value, and it's using this language of like storing in an interface value, which is very weird and very alien from how we discuss it in, say, TypeScript, right? So at runtime, if we're passing in a collection of user to a function accepting a collection of named, there's no runtime difference between those values. It's all an attribute of the type system. We can use a user as a named. There's no special runtime. The bits and bytes of that collection are completely unchanged and are the same. But here, Go is talking about it like it's a different type of value. And this is the new mental model that I started to develop. This on the left is the mental model that works really, really well for interface values in other languages, which is it's all about the static interface type. And inside, the bits and bytes of the value are unchanged. But in Go, it sounds like there's something more going on. It's more like the interface value is a container. Of course, we have the static interface type, which is named. We also have the dynamic type, which is going to be user, and the dynamic value, So this bit over here, this user, the bits and bytes of the user, are all that's in a interface value in other languages. But here at runtime, we have a much more interesting container type in that location. So my mental model was totally wrong. And that's what, had the kludge worked, it would have stopped me kind of realizing and confronting. That model from other languages that, interface is an attribute of a value, when really, in Go, interfaces are a different type of thing. They're a container for values. For instance, like you think of it as a value of named containing a user. That's the correct mental model I was starting to realize. So how does it work, the thing we've already seen, which is passing a single user into a function accepting an interface value? Well, Go, if it can, will implicitly create those interface values for you. But be aware they definitely are being created. So if you look at any level you want in the system, if you can dive down to the assembly level, whatever you like, you will see that some value, some chunk of memory is being allocated one of these interface values and being set up with a container for the dynamic type, a dynamic value. It just wouldn't work otherwise. So that's what's happening. The left side is the thing that Go's doing for us. It's creating this named interface value container and popping in the value that we passed in to implicitly make this work. So again, why couldn't it work like that for interfaces? Well, here's an example which I think really helps us understand functionally why that just wouldn't work. So we made a function here called switch items that takes two indices and a slice, and it's going to switch to the values in that slice. And we're going to use it with a slice of user over here. You can see we're just passing it in. So could Go do a similar magical thing and implicitly give us a slice of named, or sorry, in this case, a slice of interface, which, just to recap, a slice of interface can contain any value. It has a method set of 0, so there's no methods to implement, so every type implements the empty interface. So it is a container that any concrete type can sit inside. So could it work here? Could Go do something magic? Let's imagine we were writing a version of Go that did this, like a new compiler or something, and this is the kind of high-level version of what it would have to spit out, right? So we know that interface values are this different type of value. They're not the same as just the concrete value on their own. There need to be, a new piece of memory that's initialized with that magical interface value inside. So let's do that. We'll just create ourselves a new slice of interface. We'll go through and again, relying on the implicit initialization of an interface value at each point. So we're going to end up with just a different thing in memory now. We're going to have a slice of these interface values, each one of them containing one of our users. And then we'll pass that to switch items. Would that work? I think you can probably see why it wouldn't. You know, we started off with this. You know, there's the backing array of our user slice with these 3 users. If we looked at the bits and bytes, there would just be, you know, the user slice. Then our magic compiler has created the slice of interface for us to pass in instead. And that's the slice that will be affected by the function that we passed it into. So it would completely ruin the functionality of functions that we're expecting to work on their arguments, right? It would only affect this implicitly allocated slice. And why do we need to allocate a slice? Because interfaces are a different type of value. They're not just the concrete value themselves. So that's 2 answers to that question. You know, why can't containers of interface values work like every other language? The spec tells us one, you know, the spec rule-based approach, a slice of interface values is not the same concrete type as a slice of concrete values. And then secondly, this kind of vaguely intuitive but still interesting idea that we've realized that interfaces in Go are containers for values, not the values themselves. And this is, I guess, where I could have left it. But actually at that point, I was so curious. I wanted to go a little deeper and understand, you know, what are interface values like really? What's going on under the hood? This is our intuition again. What does it actually look like at runtime? At least in one implementation, the implementation most of us probably use, the standard kind of Go compiler. Well, this blue box over here is roughly like, this is a memory location. So when we declare a variable, we're reserving a chunk of memory big enough to hold a variable of that type. So what's the size of this memory location? It's the size of a user struct. And in this case, what's the size of user struct? Well, it only has one field, which is a string, and a string, it doesn't really matter, but you know, the size of a string is just going to be like the size of the slice that string is implemented as, which is only the header, not the bytes of the string. So this is probably going to end up about the size of a pointer, so it's going to be about 16 bits. What does a interface value containing that user look like? It looks like this. Size of an empty interface, and you'll see why in a sec, or the size of an interface value, and that is effectively 2 pointers. It's a pointer to the dynamic type of the interface. We know the static type of the interface already at compile time, which is named, but what's the dynamic type? What's the type? What's the implementing type? In this case, it's user. And then what's the actual value, the concrete value we've assigned to it? In this case, is this user struct over here. And because we don't know how big it would be, you know, a implementing value might be hugely bigger than the pointer. It's not always stored directly in the interface value, so it's most often going to be a pointer to that value. Okay, cool. So we'll then realize that all interface values are the same looking in memory. They're just a pair of pointers. And so they're always the same size, regardless of content. And let's actually experiment with that. Let's have a go. So we're going to create ourselves 3 different values. So first off is our familiar user value. Second off is this anonymous struct, which has twice as many strings inside. And then we have just an array of 100 integers. I'm going to wrap them all in interface values, and we're going to do a size check on every single one of them. So first off, those concrete values, and you can see, you know, completely unsurprising that a struct with a single string is half as large as a struct with 2 strings. We have our 100 integer array, so it's reserved the memory for all 100 of those 8-bit integers. Kind of interesting. And then down here, we have the size of the 3 interface values, and you can see all the same. Doesn't matter what the value inside them is, always the same. They're always the same thing in memory. That's really cool. We've learned this intuitive level that they are a separate kind of thing at runtime. And now we've kind of looked a little bit under the hood and we've understood they're all this pair of pointers. Can we do anything with that knowledge? Well, actually, yeah, totally can. It turns out the reflect package is all about interface values. So when we have a look at reflect, if we look at the methods there, value of and type of, we can see they are talking about those 2 types, right? The dynamic type as in, is it a user struct or another type that it implements named, and then the actual underlying struct behind it. And nothing, everything in the Reflect package requires interface values, specifically the empty interface, because any value can be contained inside the empty interface. And again, it will have that dynamic type and the dynamic value. So you can reflect the dynamic type, as in the user struct in this case, and the dynamic value, which is the actual struct. And we can, basically ask the dynamic type for all its fields, and then actually look up those types at the dynamic value. Super cool, right? So in this example, we've written a debug struct, a little bit like the Go formatting verb, the $V thing, %V, which is just going to list out all of those struct field names and then actually look up the values from the structs. Super interesting. And I'd recommend, as a fantastic way of testing your knowledge of interfaces, the blog post, The Laws of Reflection, on the official Go blog. Now, I remember trying to read this before I knew interfaces in depth, and I found it incomprehensible. It was so hard to understand, couldn't get my head around it. And then I just came back to it randomly after having kind of grokked interfaces on this deeper level, and it's so clear. It makes complete sense. Once you've got the logic of how interfaces work on both, either the intuitive correct level or like a runtime level, suddenly reflection becomes natural. It's just like a natural extension of how interfaces work. So we've got this new intuition, and I hope we've kind of looked a little beneath the hood. I'd like to set you a challenge now. So I'm going to give you a piece of code, and I want you to really stop and think and come up with a couple of answers, maybe based on the kind of intuitive level, maybe of course the spec level, that's interesting too, and then that runtime implementer level about this piece of code and how it could or couldn't work. Okay, so here we are. We're going to write a function called switch ivars. And it's going to take a slightly unusual type. It's going to take a pointer to an interface value as its arguments. And then it's going to do a kind of familiar swap, a pointer swap, right? So it's going to dereference the value in pointer variable 1. So actually get the value that's pointed to, store it temporarily, then take the second value and store it in the first location, and then take that temporary value and store it in the second location, doing a swap, okay? And we're going to try it out. We're going to create ourselves these two containers, these two interface values containing the user. Now, is that going to work? Think it through. Maybe pause the video at this point, which you can't do as a live stream. But yeah, okay. Is it going to work? Yeah. Interestingly enough, it does, right? And why does it work? Well, actually, nothing's going wrong here. We've created two locations, storing a couple of interface values. We've asked this function over here to swap them. Fantastic, we swapped them. Now, just to make it clear, we haven't affected these values, right? A couple of reasons why. Every single time we perform an assignment in Go, we're performing a copy, every time. One of those really interesting things to get deep into in Go. I won't go into too deep, but that means assignment, that means returning from functions, that means passing values to functions. And that also means when we create an interface value from a value, the interface value is going to contain a copy of that value, okay? So that's one reason it wouldn't work. The second reason it wouldn't work, it works, but it wouldn't affect these user values, is because we're swapping the interface values, which are different things, remember? Different things at runtime, different locations in memory. So we are going to quite happily affect these two. Now I'm going to change this code example and then consider, is it going to compile, and could it ever compile in a conceivable implementation of Go? It's probably no surprise to you here, right, that what's going to happen. So here, I haven't done the explicit allocation of interface values. I'm passing in two concrete user values to the switch function, which is expecting two pointers to interface. And again, is this going to work? Like, if you're watching this behind, recorded, definitely worth pausing, just thinking this through on those couple of levels, like spec level, intuitive level, runtime / implementer level. Like, could this work? Should this work? Okay. Now this won't compile, okay? Because a pointer to a user is not a pointer to an interface, okay? And that's again because an interface is a container value. We're just talking about different things here. I want a pointer to a container value containing, I don't know what actually, because it's an interface value, can contain anything. And we've given a pointer to a concrete type. They're just different things. We need that dynamic container with a space for the dynamic type and a space for the dynamic value. So Go is kind of saving us from ourselves, right? But again, let's just think this through. Could we do this, Could we do this? We would require, again, this implicit allocation, or I keep using allocation, a reservation of memory somewhere, probably on the stack, maybe allocated on the heap if it's going to escape, to be created, right? And again, because we're doing a switching, we'd only be affecting those implicitly allocated values. So let's create a kind of diagram here. A few things going on. So we've got these two user values we're trying out the switch function on. We would implicitly create these two interface containers, which are containing copies of the user values. So I've done that prime symbol there. These are copies of those two values. And then we're running the switch on them, okay? But the switch wouldn't work from our point of view. We'd only be switching these implicitly created interface values, and they only last as long as that enclosing function, so that from the outside world, nothing's been switched. Not the intention of our switch function. What we'd have to do, to make this work is make sure that the pointers we're switching are pointing to the things being switched, the user values. And just to recap, over here again, this isn't going to work, right? We're certainly taking the address of those user values, but we need the address of if we were going to make this work, implicitly created interface values. So that just wouldn't work. Now, do not worry if this didn't compute first time around. This is the deep part of Go, in my opinion. This is the 80-20 that really unpacks the most powerful parts of the language, the most interesting bits. So do take your time to kind of work through these examples if they didn't kind of compute straight away. That's completely to be expected. This is like my understanding of Go after a long time getting deeply confused and playing around in the debugger and just really trying to get my head around how interfaces worked on a few levels. Cool. So I think this is an interesting example of how learning works, but also how, particularly when we get a bit later in our career and we've been doing this for a while, it's very easy to stop learning. It's easy to plateau. And why do I think that? Well, because early on, we have this wonderful situation where we're both faced daily, hourly, by the minute, with encounters with our ignorance. Situations we just have no idea how to fix. Bizarre compiler errors, the tooling just doesn't work for us, all that kind of stuff. But because we've just started, because we're beginners, we have absolutely no problem with that. Our ego is not screaming at us to try and thrash around and clutch. We're very happy to ask for help, to go look at a tutorial, to go back to the specification. It's later in our career and kind of with our experience of any tool that we actually get very few opportunities to confront our ignorance. Those moments don't happen very often. So we kind of, our rate of learning is, of course, in a sense, capped because there's not that much left to learn in a sense. I mean, there's always loads, but you know what I mean? There's less to learn than when we started. And then more perniciously, we both have fewer opportunities to learn. But now we have this inflated unconscious ego that's like, but I'm a Go expert, I'm a Git expert, I'm a Postgres expert, whatever it is. And unconsciously, we just want to force that ignorance away. We want to thrash around and clutch. Or when we're an expert, come up with a completely different, perfectly acceptable solution that doesn't involve that painful spot where we know we don't fully understand something. And so that's why I think, it's certainly, of course, vital when we're a beginner to be extremely in tune with what we don't know. But it only gets more important to be completely open to the fact that we don't know something when we get later in our career, later in our whatever practice, whether it's coding, whether it's music, whether it's, whatever. We have to get more and more sensitive and more open-minded to those moments we don't learn. We need to learn, or we just won't improve at all. We'll get stuck. And really, this is one of the reasons I feel privileged to be an engineer is there's a limitless set of things to learn. Like once you're an expert back-end engineer, you still have to understand the networking stack. Once you've got your head around networking, you need to understand the operating system and all the deep complexities of our operating system. Or if you're a front-end developer, there's a whole world of like design and ethics around design, and then the whole magic of like the deep world that is CSS3 now to dig into. And that's kind of a joy of programming, right? That we have all of these opportunities to be curious and go through that actually wonderfully rewarding loop of saying, hey, I have no clue what's going on. I'm amazed by all these people who do know what's going on. And then we can slowly, just by being humble and doing the kind of legwork of learning end up in that place we never thought possible, which is actually understanding this hitherto incredibly complicated thing. So that's everything I have to say about interfaces so far. If you enjoyed that, please do have a look at this page on my blog. I've got some interesting links there that will take you to some things written about it by people much smarter than myself, people on the Go core team, people who are running Go consultancies and all that kind of stuff. So there's definitely more to learn about interfaces than what I've told you. And I hope you have some fun playing around with them. Thanks so much.
Thank you very much, Tim. That was fantastic. I didn't even know that I didn't know about Go interfaces with the small bit of Go programming that I have done. I'm going to have to rewatch your instructions and go back and code them out. Just to be
good stuff. Yeah, please do. Let me know how it goes.
Thank you very much, Tim. It was it brought up a bit of the pain of learning generics and inheritance in Java 2 years ago. So thank you for that. If David, do we have a time for one quick question?
Of course.
Or should we move on? I have one question for you, Tim. So JetBrains have a Go IDE Goland, and we have 10 JetBrains licenses to give away today. So my question for you is, would you recommend it, or have you ever used Goland yourself?
I love Goland, I have to say. I'm a huge fan of it. I've used it for a couple of years now for TypeScript and Go. I really like it. It's got Vim key bindings, which was like a big kind of blocker for me adopting IDEs. Like, it has good Vim key bindings. It runs fast, not as fast as Vim, but it runs fast, and it just means I can just focus on coding. Like, I don't have to worry about things not being supported for latest language version. The debugger is amazing. Integrated console tests just run with a keyboard shortcut. I think it's fantastic. Really, really love it.
Thanks very much.
All good.
Thank you very much, Tim. Thank you so much for joining us today. Next up, we have another Go programmer, Daniela Petruzalek. Oh, sorry, Daniela. We both pressed buttons at the same time. Hold on. Oh, you do it. I'll stay back, Ricardo. Sorry, Daniela. I'm making a mess of stuff here. So, Daniela, I've been following your work for quite some time, and we've had a couple of email exchanges over the last while. It's a great honor to have you on stream with us here today. For anybody that doesn't know, Daniela Petruzalek has a wonderful video series. She has a wonderful tutorial on making Pac-Man in Go, which was very well received and is a fantastic starter project. That's the one I plan to break out when I'm going to go practice the interfaces that Tim has just spoken about. Daniela, you're always learning stuff that isn't even code related. So my question to you is, what's the oddest thing you've learned just for the sake of learning it?
The oddest thing, oh my god! I'm learning Japanese. I don't know if that's an odd thing, but that's my current passion, and because I love anime and games, and so Japanese resonates a lot with me, and that's the thing I'm spending my most time learning. That's not coding related now.
So, as a Brazilian top coder now speaking English, you've decided to go and learn Japanese. How that's amazing. Okay, you touched briefly on that. You're a retro game collector. So have you got anything in your arsenal that you're especially proud of, or that you're riffing off right now?
Yes, definitely. I think the thing I'm most proud of. Yeah, I'm a bit divided now, but I have a Wonder Mega, which is a Mega Drive combined with a Mega CD. And that's a very rare video game, but also I have a PC Engine collection I'm very proud of.
You mentioned briefly in the exchange we had before the talk that you did a talk in Belarus that resonated with you. Was there something you'd like to say about that?
Yeah, Belarus was. It was one place I never thought I would step in before, and then suddenly I got this invitation, and it was in behalf of the Go Away Fest, and I was really impressed by it. The city is so big and so clean, so people are so polite. It gave me a very good impression. That was so remarkable.
That's amazing. We've had a couple of Go talks. We had David McKay on Cloud earlier on today talking about Go. Maybe you guys have presented together in the past, and obviously you saw Tim just before your own talk there that was talking about Go. And we did have someone on earlier. I think it was Was it Imad Shan that was talking about Spark? No, it wasn't. It was Aon Roy over on the AIML talk that was using Apache Spark. So there has been a lot of interest. I mean, you seem to be staying very relevant on really new technologies. Where do you find the time?
Yeah, I don't know. I think I'm just passionate about these things. Like I really like. I mean, I come from a database background, so that's why Spark resonated with me. But Go was because in the beginning of my career, I used to be a C++ developer. So I keep finding interesting things to do, and then when I find something that catches my attention, I just want to learn about it, and that's why, basically.
That's fantastic, and I know you've taken a bit of a break to re-energize yourself for the last year, and we're delighted to have you back on the talking circuits, and we're really looking forward to hearing what you have to say today. Without further ado, myself and Jan, I think we'll back off and let Daniela perform her talk. Unless you have a question, Jana, of course.
Question. I'm looking forward to this now. Yeah.
The stage is yours, Daniela.
Let's share my screen. Hopefully you'll be seeing my deck now. Okay, so thanks everyone for coming to my talk. This is Apache Spark 101. And I'm Daniela Petruzalek. I'm a tech principal at Torus UK, and also a Google developer expert in Go and GCP, like David was mentioning. And yeah, so this is an introductory talk to Apache Spark. So probably this will be very interesting if you're beginning with Spark, or maybe you don't even know what Spark is about. If you're more experienced, this might be a bit basic, but I think still you might find some interesting stuff, especially in regards to Dataproc, which is Google's offering of Spark in the cloud. So let's see. So this is the things I'm planning to cover in the content. So first, what is Spark? Why do we use it? Basically, what's it's trying to solve? And then how it works, a little bit of driver and workers, RDDs and data frames, a lot of technical things. And in order to make those things a bit more interesting, my idea is to use a lot of live coding. So please, let's pray for the demo gods that everything works as planned. And finally, I'm going to try to demonstrate a little bit about how Spark works in Google Cloud. So without further ado, the problem of big data. And this is, you probably have heard a lot about big data, but big data actually is has a very simple definition. It is when data doesn't fit in a single machine. And this is the original definition. This is the first time the term appeared in the literature. It was a paper by NASA in '97. But ever since then, the industry seems to be a bit obsessed by defining big data in any number of V's, like volume, velocity, and whatever. You don't need to memorize this. Just think, if it's too big for one machine, that's a big data problem. And that's exactly what Spark's trying to solve. So Spark defines itself as this unified analytics engine for large-scale data processing. This is copied word by word from their website. But what it really is like a collection of tools to work in data in a distributed way, and has some very interesting tooling, like support for SQL, support for machine learning algorithms. It's a very mature thing. I really like Spark from that perspective. It has a couple runners, and that means where you can run Spark. So you can run it either locally, and that's a very interesting benefit because you can do your tests and run like some experiment in your local machine before running in a cluster. And it's the exact same code. So, and also you can run on Yarn, Mesos, Kubernetes. It has its own cluster management tool as well. But this is really, they don't recommend this for production purpose. So if you're running in production, you either want one of those, like Yarn, Mesos, or Kubernetes. And in terms of programming language, Spark is written in Scala. So it has native support for Scala, but also Python, R, and Java. For the examples here today, I'm using mostly Python. Actually, only Python. So there are two things I want you to keep in mind when thinking about Scala. And those are the main issues that are a bit difficult to wrap your head around when you're beginning. But with experience, with time, you'll get to it. So, which is basically, where is my code running? Because you're going to be juggling your code between driver and workers. So you need to be aware that some things will work on the driver, some things will work on runners or workers. And other point is, where is my data located? Because this is not that something that you usually need to deal with, but will impact performance. Because if your worker needs to do some work in data and that data is not available to that worker, it will need to do like some moving of data around, and that's called shuffling. So, and in this type of architecture, network transfer is usually the bottleneck. So you need to minimize that. And there are a few techniques you can use to do so. So how does Spark work? The thing you write, the Spark program, is called also the driver program. So you write your entire program thinking from this driver perspective, which is the program responsible for handling all the resource and giving operations. And it talks to Spark using this figure of what's called a Spark context. So every time I want to distribute some operation, I'm going to say, Spark context, do this for me. And then what Spark context will do is talk to the cluster manager and see what resources it has available. And it will spin the tasks in these worker nodes and say, oh, task A and B will go to this worker, C and D go to this other worker, and so on. Here we have a figure with 2 workers, but keep in mind that you can have like 1 if you're running locally, or you can have hundreds or thousands of them. This is really the secret sauce. So let me show you a brief demo, and hopefully you'll be able to see my screen now. Okay, for this demo I'm using PySpark, and PySpark is the imagine the Python shell, but with Spark support. So this is PySpark with support for Python 3.8. And here you see that we have this Spark session available as Spark. So if I type Spark, this is my Spark session variable. You also see sometimes mention of the variable SC. SC is short for Spark context. And this is the thing that communicates with the Spark cluster. So one way to, they kind of are the same in a sense that they provide communication with Spark, but the Spark session variable is the modern way of doing so. And SC used to be the standard way before Spark 2.0. But the way it's easier to grasp this concept is that Spark is actually a collection of contexts. So you actually have a Spark context inside this Spark session variable, and you can see that they actually are the same. You have a few other contexts, like the SQL context and others. So you can imagine a context is your way to communicate with a resource. That's all that matters about this. And so let's start with having some traditional Python collection here. We have a range from 0 to 100, and A, in this case, this is Python 3, so A is a lazy collection. In this case, we have just a definition of range. So if I want to materialize this, I just say list A, and then I have my 100 numbers from 0 to 99. Since this is a Python code, this is running the driver's memory, and that's what I want you to pay attention to. If I want to perform an operation like I want to double every element in this array, I can use this map operator from Python and apply a lambda function. And I have a new variable that's with all the values that are double. Basically, this traditional Python code. Okay, so every Python operation I'm doing here in PySpark is running from the driver perspective. If I want to distribute this and say, do this work in the worker, the same work I'm doing here, I can say, I can use the Spark context and see parallelize A. And now you see that C is not a local variable anymore. It's not a Python variable. It's this thing called Python RDD. And we're going to see what an RDD is in a moment. But from this point, I'm working with Spark and not on the driver perspective anymore. And
you can see easily that if I try to do the same map operation I did before, let's see, x times 2, and I want to give c as a variable, I'll get an error because that's not like a local variable anymore. But luckily, we have Spark operators that can do the same for us. So I can use c.map, and I can run the same operation, and then here I have a different RDD with the result of that operation. So if you need to bring back something to the driver, you have some operations for that. You can use actually the collect operation, and then now I have my local variable again. And that's what I mean by running different contexts. And what I really want you to understand is that when I say this c.map and I have this function inside parameters, this runs in the worker code, not in our driver code. So let's have a look at a bit closer to what an RDD is. So I'm talking RDD, but RDD is a resilient distributed data set. It's resilient because it's fault tolerant. Distributed because it can span from one to several nodes, and by several I mean like hundreds of thousands maybe, but might be just two. And data sets because they're a collection of data in memory. One thing you should be aware is that nothing is going to happen. I've been writing this code from the driver perspective, like ABC. I have this RDDs, but this is actually just a graph representation of the tasks that the Spark framework must do to get to a computation. It doesn't actually evaluate anything until you actually have no choice to evaluate. Like for instance, when you trigger a count, Spark can't do anything but give you the result without actually processing our steps in the transformation. That's why it's lazy. So there are some operations that I call actions that will actually trigger the evaluation of those RDDs. And RDDs nowadays are considered low-level APIs. There are some things more interesting now that are called data frames, which are abstractions on top of RDDs that gives us a schema and a few more advantages. And the second thing I want you to keep in mind is that every time you add an operation to an RDD, you're actually building this lineage, this execution graph, where you're constantly adding steps in the chain. And that's exactly why RDDs are resilient, because you're building this from the context of the driver, and the driver knows all the steps required to basically produce this last bad lines RDD. And let's say this is running in a worker, and warnings RDD is running in another worker. If something happens here and it fails, the worker node fails, the driver knows all the steps required to recompute this and build this using a different machine. And that's exactly what it does. So when it fails, it will spin a new node and say, oh, this is the piece of information I'm missing, so please rebuild this. So that's how the driver works. It keeps this execution graph in memory and keeps giving this task to workers until it's done. So now, to make things a bit more interesting, let's look at how we can use Spark on the Google Cloud platform. And the name of the product here is called Dataproc. And here, I already have a cluster created for this example. And but here, if you want to create one, it's really, really simple. You can just almost like next. You can just specify the size of your cluster, what's your region. You can configure what's the master node and the worker nodes, and so on. But I created this already. It actually is pretty fast. It's like 2 minutes operation. But I created one, and what I did for this demo is to create a cluster with both support for Anaconda and Jupyter notebooks, because that makes a bit nicer for us to explore. So I'm going to use this Jupyter notebook so we can run Spark code in the cluster. And let's pray for the demo gods that this are going to work. Yeah, I was facing some slowdowns earlier today. Let's see. I have a fallback plan, and we can also run this locally if it doesn't work. Let's try again. Yeah, I was afraid that this might happen. So come on, Google. Yay, finally. Okay. So this is the notebook interface, and here already this is actually something I was experimenting with. But if you want to create a new notebook, you can create this with PySpark support, and this works exactly the same way the console I was showing before. So I have my Spark Spark session variable. Yeah, it's a bit slow now. I also have my Spark context, and hopefully this will work. What I want to do here is what is called the hello world of big data. And what I'm going to do is load a file, and let's hope this works. I'm looking at loading a file from my storage bucket from DevFest 2020, and this is called Shakespeare.txt. And this actually is an open source file that has all the works of Shakespeare. Let's hope that this. Let's just zoom in and remove this. Yeah, it seems to be a bit slow today. Come on, come on, come on. Yeah. Okay, maybe I'll try this. I'm not sure why. I was just testing this earlier today, and it was working fine. I'll fall back because we have a limited time. I'll just fall back to the to the local version, because we can actually do the same things here. So let's see. I'm going to load this file, but now instead of loading from GCP, I'm just going to load this locally. And okay, we have this file. This file is an RDD, and I want to do the classical word count type of algorithm. And in order to do that, you need to split this file into words. And to do that, since I'm using SC, now everything that I'm going to type here is going to happen inside Spark. So I'm going to use this. And for each line, I want to basically convert it to lowercase and split into words. So now I can have a look at this. So I have a few words. And the way this algorithm works is that for each word, I'm going to pair with the number 1. So again, to do words, I'm using a lambda function to just create this word pairs with ones. And then I have a final step, which I'm saying for those ones, I'm going to call reduce by key. And using this function, I'm going to, the key in this case is the name of the word. And so for each word, it will take pairs by pairs and add the number that's next to it. So we can see the result of this here. There are a few debug information here, but let's run this again just to clarify. So we have like 99 times the word project. This is actually some of the disclaimers in this file because it's open source. But okay, I told you that this is an RDD. RDD are not very nice to work with. So let's convert this to a data frame. And the way you can do this is using this very nice 2df function. So I can have word, and I can have count. And what this gives me is now I have this data frame thingy that is not just the data, but also I have this schema, like word being a string, count being integers. And I can have now some convenience methods like show, which actually produces this kind of output. Just keep in mind that every time I use show or any other things, show is an action because I can't show anything if I don't evaluate it. And I'm running the data frame all over again from the beginning. There are some ways you can cache some steps so you don't run everything from start. But yeah, basically you need to think about what kind of algorithm you're going to build to see which kind of operations make sense to cache and which doesn't. So okay, if I want to know which are the most frequent words in Shakespeare, I can do just this. So I can order by the column count and descending way. And this is another data frame, so I can just say show. And here you see that you have D and I a lot. And if you are used to do processing with natural language, you know that these are what's called stop words. They are words that don't give a lot of meaning. What we can try to do is get rid of those stop words. And there's this library called NLTK that you can use to do this. So from NLTK.corpus, I'm going to import this stop words resource. And my stop words will be stop words, not words, and I want to load the English stop words. So here, remember, here I have a local variable, so I need to distribute this in a way so Spark can use it, because I can't link this with the data frame I just created because they are in different contexts. So now what I'm going to do is create this stop words data frame. But like I said, you have some better alternatives to create data frames using the Spark session instead of just using the context. But here I need to do a trick, which is a bit hacky. But since this is a collection that has only one column, I need to actually convert this to a tuple. So I use this. Yeah, this is a weird map operation, but please bear with me. That's the way you have to do this. And here the last parameter of the function is just the column name. So now I have this data frame of stop words. You can see here a preview of those. And you can, now that I have two data frames, I can link those together because now they're in the same context. I have both df and stop words df. And a really nice way of doing this is I can actually register this as a table and use a SQL to do the queries. So creator replace temp view is my function, and I'm going to give this a name called word count. And I also going to register the stop word data frame, creator replace temp view stop words. And now I have those two registered as to Spark SQL, so I can use Spark SQL and do queries on it. And those are just your standard SQL queries, as you know from any other type of relational database. Here, for instance, I'm just doing a select star. Please bear in mind that if you just do this, you're going to get a new data frame. So I'm going to use the show operator here. This is the same result we were seeing before. But now what I'm going to do is, let's say I want w.word and w.count from, now I'm giving an alias to word count where not exists. And then I'm doing a subquery to say select one from stop words s, where s.word equals w.word. And I'm going to close this. And now I have this data frame without the stop words. It's still a bit messy. I forgot to order it. So I can say here, order by to descending. And now I have a very nice representation of Shakespeare. Yeah, you can see that this didn't work very well because the stop words library is not prepared for those classic English stop words like to, alt high, but still it's a bit better. We got rid of the I's and me and my and so on. So yeah, maybe
we need some kind of stop word for this type of English. But yeah, this and another nice thing, we can actually take this and create a data set from it. And this is the last thing I want to show, is that you can actually, this is the same data frame that has the query above, but you can actually have a look at how Spark processed that thing. And this is the physical plan of execution, the same way a database does. And this is where you can actually have a look to see if you're being efficient, if you're transferring too much data. In this case, probably since stop words is a very small table, you don't really want to do joins using this table. You can actually have some smarter strategies like using broadcast and other things. But unfortunately, yeah, I'm within my time limit, so unfortunately we can't show this today. But yeah, this was a very brief introduction to Apache Spark. Hope you enjoyed. If you have any questions, feel free to send to me. And yeah, sorry for the problems with the demo. I really want to show in Google Cloud, but you know, demo god.
I think you did fantastic, Daniela. Thank you so much.
Sorry.
Have you any parting words? You being our last guest.
Oh, I'm the last one.
Yeah, we saved the best for last, of course, Daniela.
Okay, good. Yeah, I hope everyone enjoyed, and I definitely missed those things in person, because now we will go to a bar or something and have a happy hour. But I hope everyone does this at their homes now.
Maybe next year, Daniela. Maybe next year we'll do in person.
Yes, definitely. But thanks a lot again for this opportunity. I hope everyone enjoyed.
We did. Thank you so much.
Muito obrigada.
Nice. Bye-bye.
Bye-bye.
Bye.
I think our host for the day, Ricardo, is going to do our final words. But from Yana and I, thank you so much for joining us. And we hope to see you in person soon. As they're saying online now, I hope you're staying positive and testing negative. Have a great day.
We are about 8 hours streaming live. Thank you for joining us. Thank you for your dedication in these difficult times, but also interesting. It's just the first DevFest that has this format. That's why we are going to ask you for your that's why we are going to ask you for some feedback. We are going to share the feedback link shortly, but also we are going to invite you for the DevFest after party. It's gonna be a meetup link, and you will be joining a room, and that room, all the people after party will be there. I hope that the mood of the after party will be like something unusual in these difficult times. So you are free to bring your own beers or your drinks. And we are going to leave this page open for a few minutes, and you are open to join this party. So from the GDG family, many thanks for joining this DevFest 2020, and I hope to see you in 2021.